Good morning, everybody. Welcome to the 23rd edition of the SFSCon, the South Tyrol Free Software Conference. It's a huge pleasure to have you all here today and tomorrow, 2 days full of many contents, many experts sharing their knowledge, their expertise together. We have more than 110 speakers, 110 slots of packed knowledge to inspire you for the next research and development projects you will go to do using software freedom. So I will give you a little bit of an overview, logistics information about the South Tyrol Free Software Conference 2023. And afterwards, we will have the official opening done by our Director of Innovation and Tech Transfer, Vincent Mauroy. But first, I would like to start thanking our supporters, which are companies who support us, covering a huge part of the costs of the organization of this conference. And this allows us to not ask for any tickets. So we can give you free tickets thanks to these corporate sponsors and thanks also to the European Union, who has also supported the conference. But let's start with the Platinum supporters. This is in alphabetical order here. We have Eclipse Foundation. As you can see by the socks I am wearing, we are proudly members of the Software-Defined Vehicles Working Group of Eclipse Foundation, and we will also have Sarah Gallian here giving a talk in the main track. Thanks you very much for supporting us. We have Gruppo Foss. Gruppo Foss is a company with many sites in Italy, also outside Italy, in Europe, in other regions in Europe, and doing research and development in many R&D projects we do with companies and organizations here at Neue Tech Park. They bring in the knowledge about microprocessors, software development, and also hardware development. We have Red Hat since some years as supporters, and we have also many speakers coming and sharing knowledge by Red Hat, and we have Telmecom since many years, which is a local company doing also research and development support, mainly also in smart cities projects, IoT topics, and we will have also a presentation not directly by Telmecom, but by the city of Merano, who is using Telmecom as an innovation provider. Then we have Charles Schulz and Waits. It's a company from France. We are really happy that Charles supports us. And as silver supporters, we have IT ServiceNet and Made in Cima. IT ServiceNet is a consultancy company for free software solutions in Italy, part of RIOT, Rete Italiana Open Source, and Made in Cima is a web agency which is working in many R&D projects with us, and by the way also has implemented the website of SFSCon. Bronze supporters, we have Chris Meyer mainly with 1006.org, expert in Postgres databases, and in the last months heavily involved in many R&D projects because he's also an expert on AI tools, so you can imagine how much work he has at the moment. We have CatchSolve, a startup here at Neue Tech Park, specialized in software quality, automated testing. Endian, many of you know, Endian has been founded in 2003 by Rafael Valazza, also based here at the Neue Tech Park. It's a cybersecurity company. They started with the Endian firewall and has grown in a very successful cybersecurity company. And last but not least, Pear. Pear is a company specialized in digital marketing, I would say. They also have an own multi-channel marketing. They also have an own TV channel. So these are the companies who support SFSCon this year. I would say we make an applause to these supporters. Thank you. I have to switch because... And as I said at the beginning, the European Union is supporting us with the ERDF, European Research and Development Funding, and we have many partners. Some of these are well known, like the Free Software Foundation Europe, but also projects, EU projects like Zoom, and research organizations like the Free University of Bolzano is supporting the conference every year. Some information about side events. We have grown. There are many side events now. It's not just a track. It's not just 4 tracks or 5 tracks. It's also side events. One side event and side track I would like to underline is Data for Smart Health. It will be in the auditorium, which is in the A2 building. I will show you on a map also how to reach it this afternoon, organized by the Free University of Bolzano and our partners from France, from Paris, OW2, organize an OW2 track specialized on the topics they are working on. And Zoom, as I said, is an EU-funded project, so it's Zoom with 3 O. And it stands for open data, open source, and open hardware, if I'm correct. And it is a track and also a workshop organized during SFSCon. A very nice side event we are organizing since last year is also the reading of a book, the book which has been written by Matthias Kirschner. I see him in the back there. Matthias is the president of the Free Software Foundation Europe and has written a book. It's a tale for children. He has written it in German as original language, and last year we had children from schools, German schools here, reading the book. We had a book reading. This year, so after last year, the book has been translated in many languages. There is an English version, there are Arabic versions, and since this year we also have an Italian version, and therefore this year we invited Italian schools, so pupils from Italian schools to hear the reading of Ada and Zangemann. There will be more than 90 children coming, joining, and having the reading. But not only children are interested in the book, we will have a reading also this evening as one of the last sessions of the conference in English. So if you are interested to hear the book, to meet the author, you have the opportunity, and use this opportunity, please, to maybe get inspired for how you can tell what software freedom is about. We have a hackathon which takes place, 24 hours hackathon. We'll start upstairs. I show you a little bit on the map We are at the moment here in the A1 building. Then there is the A2 and the Piazzetta. These are the three things you should know and remember of the park. So as I said, we are in the black monolith in the A1 building. And if you exit from the A1 building, you can go straight over the Piazzetta to the A2 building, which is the same construction. It looks, it's the twin building of the A1, historical buildings. So you can enter by the door. You have passed a long corridor, all the heavy labs we have in the A2 building. And at the end of the A2 building, there is a stairway, the stairway to the auditorium, in this case. So you can use the stairway to the auditorium. Please don't shout while going upwards, because between the stairways and the auditorium there is no glass or door or so people can hear you. So go upwards quietly, do not disturb who is giving the talks. And you will find many things, like many presentations like the data for smart tourism in the A2 building. Outside you find some maps around, so you can organize, but you can also ask, of course, our staff and volunteers. Stickers, don't forget to use our stickers. We have many stickers available and also on the booth, but also stickers from our supporters. And not only stickers, you should also use the vouchers you get. Thanks to Vates, our supporter, you get free coffee. And we have food trucks outside on the Piazzetta for the lunch break. The blue ones are for the SFSCon participants. The green ones are for the hackathon participants, so those who are also participating to the hackathon have additional vouchers for the Noisteria, but those who are in this audience are using the blue vouchers. Okay, I think I have given you an overview about how we got support, and I will now give the word to our Director of Innovation and Tech Transfer, Vincent Mouat, who will officially open the SFSCon 2023. Thank you, Vincent.
Okay. Next. Good morning. Good morning from my side also. Very nice to see so many people here. So the last figures I had was more than 750, which is not bad for today. So welcome everybody, both here physically and also online. Yes, so first of all, SFSCon, for most of you it's known. For those who don't know it, that's an initiative that started already back in 2001 by the Linux user group here in Bolzano. And since 2005, we are organizing jointly the event. So we can really say that Bolzano, Linux user group, and Neutech Park are part of the pioneers also of free software and open data, especially also here in the region and in South Tyrol, with an impact which goes way beyond our region. Patrick already thanked all the sponsors. I don't lose much time about it. So thank you also from my side for all the sponsors making that possible, making it also possible that it is free, not only free to attend, but also free for coffee and lunch. And of course also the contributions of the European Regional Development Fund are also very important. They are contributing to making this possible. First of all, maybe about Neu, for those who do not know Neu, because there are some people coming from far away. So what is Neutech Park? Well, to start with, everything is already in the name. It's the nature of innovation, and it's something that we take really very seriously. It's not only a name, we live it every day. And the purpose is using technology, research and development to develop the new things, new products with a lot of added value, but most of all, to change the world in a more sustainable world. That is, let's say, one of our main tasks here at Neutech Park. So what are we doing? We are an innovation district, so we are linking economy, science, we are boosting R&D, and also investment locally in the local companies, in startups, and driving also new ecosystems. You only saw the entrance map that Patrick showed. There's much more in the park, so there's 12 hectares. Only 4 of which is being built now, but we have a very ambitious plan, concrete plan, already completely financed until 2030, where it will be further expanded with additional buildings, but most of all, not only buildings, buildings really full of people. So we are only building one building next to the other, only if we have a need to do so, and we have already waiting lines of companies and startups who want to join us in our endeavor. So we do not do everything. We have 4 main focuses. So we have a lot of projects in green technology. We do a lot in food and health, also with biomedicine from URAC, with the University of Bolzano. We do a lot in automotive automation. There's a big supply chain here also in South Tyrol that is supplying big car manufacturers worldwide. And therefore also we support them with whatever they need in research and development. And of course the focus of today is digital. Now what do we do in digital? First of all, you see here a kind of a strategy house. That's something that we developed during the last year. For each of those technology sectors, we identified 3 main areas where we will focus on and further develop ourselves. And the purpose is that we really become proficient pioneering in those areas. That's why also we have at the base of the house, we have our kind of values of our strategy. So we only work on things that are excellent. So doing high qualitative things. Pioneering things means being also bold enough to do things the first time, new things. And sustainable, firstly for the nature, environmentally, but also sustainable business models. So not only startups that only live for 2 or 3 years. No, we really want also to develop startups and that they continue to thrive like companies and stay on the market. So the main purpose at the end, everything that we do is to establish a digital backbone to enable smart green regions. And that is something I think we are quite unique to have that focus, to build that backbone. And that will enable, or it enables already now, the participation of a lot of everybody at the end who wants to participate, to innovate in the digital world, can access through our services, but mainly also through our open data, to data that they can use for their purposes. We have 3 main pillars. The first one is Internet of Things. That is at the end everything that we need to generate the data, normally with sensors. We also develop specific sensors needed for specific scopes. That is the purpose of all those activities. Once you have the data, you have to transform it into value, which can especially be done with artificial intelligence. It's also a focus of ours. And centrally, not least, but I would even say the most important one is the Open Data Hub, which is that platform where the data can be found, which is often difficultly to find to be able to develop your solutions on. So that is a kind of a platform already in mobility and tourism. We will expand it with agro-automation, and also in other areas we still are defining those new data spaces that we will develop in order to create a data pool for innovation. Now we have also a bold vision that we defined also better at the end of last year. So we choose to be one of Europe's leading next generation science and technology parks, to serve best our territory and its companies, Europe's values and the planet's future. Now that's not an easy phrase, and maybe I explain also what is mentioned with next generation. First of all, the N stands for nature and sustainability, which is also for us the highest priority. So doing sustainable things for nature. European innovation strategy, very important. That means that we are full support of European policies, European values. That is our main driver. Also, with all our projects that, of course, are also partially funded by Europe, to at the end help Europe and contribute to the European strategy in innovation. The X, you can imagine it was not easy to find a word with an X, but we found it. It's extramoenia. It's a Latin word which means beyond your own walls. And at the end, it's very important. It's very important at the end for us also. It's technology park. It's open innovation. So doing things together with others. And that will leverage your capabilities, your own company. And at the end, it's something that's always more and more needed because nobody really has the full know-how. And we need so much know-how in different fields to be able to innovate and bring innovative products to the market, that open innovation is very important. That is what we stand for. That is also center. We do a lot of projects to involve companies, startups, and also the ecosystem in contributing in what we are doing. And the T, the last one, is also very important. Maybe we distinguish ourselves also a lot in that related to a technology park. We are very, very cautious that all what we do, or most things that we do, they have an impact locally for the territory. Now, maybe also European values, that's also important, maybe to remind them which are those values. First is human dignity. Second is freedom. Third is democracy, equality, rule of law, and human rights. I didn't invent myself. Those are really the Europe values. And why do I show that? Because if you look now to the values and the added value of free software, that's from the Free Software Foundation Europe. Those are at the end the key values of free software. We are talking about autonomy. So free software should help you to develop and maintain tailored software that suits your needs, not what is mostly wanted to satisfy business models. You can share and copy. You can reuse code. It thrives competition. It also pushes collaboration. There's no lock-in effect. It spurs innovation. And it even that's something that most people don't think it's possible, but it's really also high security, because the whole community is taking care of the security and tackles it very swiftly. Now, if we see those characteristics of or the values and the added value of free software, well, at the end we can put them to one of those values. It was sometimes difficult because one of them, like collaboration, can also be attributed to other things. But at the end, by implementing free software, what I wanted to say is that it's fully in line with European values. And maybe we should, in Europe, do even more with free software in order especially to make data and know-how available as broadly as possible. To conclude, just a little bit, so my insights, we are talking a lot of AI. There will also be a lot of talks also today and tomorrow about AI. I just made some thoughts, just some takeaways as a final slide. How will AI revolutionize open principles and free software? First of all, I think AI will spur and contribute to a high collaboration and innovation. So the new breakthrough AI models make it possible to control code, automate also the generation of code, and that will also lead to further innovation in the free software field. Accessibility, it will increase accessibility with especially those new, very efficient AI translation tools. They will help communities, free software communities, which normally are very international, to work together in a more easy way and more accessible way. And that will at the end also give much more potential to free software. Automation, so with AI you can automate a lot of things, code development, checking the code, control functions. So that will, I think, also improve at the end the efficiency of the whole free software process and lead also to more efficiency, innovation, and time to market reduction from solutions to the customer. AI ethics, that is something at the end that the open data community can give to the AI, because the open data community, already since its beginning, one of the important, let's say, values were transparency and user control. And we cannot say that that is really the case everywhere in AI at the moment. And if also the open principles and the free software people with that mindset will also contribute in developing AI in a specific direction, we are more sure that it will be also transparent, and with user control. And the last one is data commons. So as you know, AI, the better AI is, the more data you need. So free software is at the end also the generation of a lot of data that is available, broadly available, that can also be used then for AI models to be trained and to improve themselves. And also gives the possibility to give that information, that open data, to research and to work with AI together with this data on new solutions, which is why we also have that Open Data Hub. Yeah, that is what I just wanted to say. A small introduction about the Neutech Park, our values, how they link with free software, open data, and how, according to me, AI can positively revolutionize and give more potential to open principles and free software. So thank you again from my side, and enjoy the 23rd edition of the SFSCon. Thank you.
Thank you very much, Vincent. Thank you. Thank you for the official opening. Now, the SFSCon 2023 has started. I've got a message around 10 minutes ago. Still, people are coming, and we had 812 check-ins until 10 minutes ago. So we are a lot of people eager to share knowledge. That's great. That's great. Thank you very much. And now, a good friend of us of the SFSCon, Simon Phipps, Director for Open Standards and EU Policy of the Open Source Initiative of OSI, will talk about regulation, AI, and the state of the art, the state of software freedom in Europe. Welcome, Simon.
Thank you very much. Thank you. Buongiorno, and guten Tag, and there's other languages here as well. So I was looking in my calendar, and this is my 15th year at SFSCon. And when I first came, the speaker dinner could all sit round one table. And last night there was a speaker dinner that was just that little bit too big for the Fiera restaurant next door. So now what's going on here? Here's the sort of stuff that I would like to talk around for you. And I'm a little less upbeat than our previous speaker about some of those technologies. We've been doing open source for 25 years this year. And we've been doing free software for 40 years. And in that time, there's been a change in the adoption of free software that really reflects the change that we see in SFSCon. That is a change where there are a lot of people using it. There are so many people using it. Let's just make sure I've got the right slide. There we go. There are so many people using it that it is now 90% of all software. And in fact, it's so significant to Europe that it now makes up 10% of the software, of the IT systems economy in Europe. Now, that means that although there are 800 plus people at SFSCon, we are only the tiniest fraction of the people who are using free software in South Tyrol. Because everyone who is using software in South Tyrol, and I suggest to you that is everyone, is using free software. And that presents several challenges to us. One of the challenges it presents to us is what do we mean by free software in this generation? Now, you'll see that my hair has gone grey since I started presenting here. That is not just, Frank has lost all his since he first presented here. That is not just the stress of presenting at SFSCon. It is also because we are now getting old, and there's a new generation coming in. I see you all at the back there. You thought that I wouldn't see you sitting back there. How many people are attending SFSCon for the first time this year? Could you raise a hand? Thank you. So we did that last year, and we got about the same sort of ratio, so there's still a flow of new people coming through. So now, what am I going to tell you about? Well, the first thing is that it isn't just geeks that trust and use free software and open source software. The organization that I work for at the moment, the Open Source Initiative, is the steward of something called the Open Source Definition. The Open Source Definition describes which licenses give you software freedom in addition to the GPL family. And that definition is now so widely recognized around the world that it's beginning to get written into laws and regulations and policies. And what that means is that if you run a company that would like to make money, it is good to identify yourself with that definition. And so people everywhere want to leverage that definition. They want to call themselves open. They also want to call themselves free. And both of those terms are widely used, but unfortunately, they are also widely abused. And we have seen through the last 25 years a growing trend in people calling themselves open when really they aren't. Sometimes they do it as a predictable part of a business model. So the first company to do this was a company called Sugar CRM, who there's some people nodding their heads, and there's most people in the room who have no idea what I'm talking about, because Sugar CRM, which was the darling of the world of open source and free software in the mid-2000s, has gradually followed a path of taking away people's freedoms as developers and as users. And eventually, about 2 years ago, they completely eliminated their community edition. They are now a purely proprietary software company. They used free software to make a market. And once they had the market, they didn't need to be free software anymore. And so they changed their license. And the same thing is happening in the database market. You might have run into the business software license. Don't call that the BSL. There's another license called the BSL. You could call it the BS license if you wanted to, or you could call it the BUSL, but one of those are not BSL. And then there's the server-side public license. And then there's the folks at MariaDB flirting with non-compete licensing. We're seeing people continuing to follow that trend towards taking away your freedoms once they have been able to leverage them to make a market. And then cloud computing happened. And unfortunately, the free and open source software community pretty much ignored it. Some people tried very hard to make good software that was free software and did cloud, and Frank's going to be talking to us after I've spoken. But the vast majority of the cloud computing world, the software freedom ends with the vendor. The vendor enjoys software freedom because they're integrating all that free software. They don't have to start at the ground, they're able to start at the cloud. And then there's GitHub. What can I say about GitHub? GitHub has happily wrapped itself in the flag of free software, but from the beginning was not too concerned about whether the software it was hosting actually was free software, and is still not terribly worried. They now have the world's largest training database for artificial intelligence in source code, because many of us decided we would trust them to look after our code for us. And then there was Bitcoin. I shouldn't mention Bitcoin. I say bad things if I mention Bitcoin. So let's talk about AI. Let's talk about AI. So artificial intelligence. We hear many people talking about wanting open AI. Now, what do they mean by that when they say they want open AI? It's not completely obvious what someone means when they say they want OpenAI, because it turns out that the hardest part of AI is not the software. AI has got many aspects, and yes, it's common for people to put the software under open source licenses. But there's a whole lot more to both the cycle of making an AI and the content of an AI than just the code. This pipeline along here contains many traps for the unwary. If you're going to build an AI, there are lots of things you have to do. You have to gather some data together. You have to train a model to, that is, do statistical analysis on your data and look for patterns. You have to decide which of the statistical data points you found during the training matter and give them weights to show which ones should be used in the future processing for your application. You will then need to tune up your model. And then eventually, you'll use the model in an application. Now, if you get all this wrong, it's doing some serious things. AIs are already being used for many things in the world. They're being used to decide the sentencing for prisoners in courts. They're being used by governments to decide which benefits people should get. They're being used to decide which migrants should be allowed into which countries. They're being used to decide how to allocate funding according to political priorities. They're being used to drive cars in city streets. They're doing some serious things, and if this goes wrong somewhere, someone ends up in jail or dead. This is serious stuff. This is not writing a program to play Snake on your watch. This is serious computing that's going on here. Now, the angle of attack that many people in the free software community take on AI is to ask whether copyright is involved in all this. And I'd suggest to you that that is exactly the wrong question to be focusing on. The reason it's the wrong question to be focusing on is that the legal landscape around copyright is very complicated. It varies country by country, and it has many loopholes that you can use both to enforce and to avoid enforcement. And if we put all of our weight behind claiming that AI is stealing our GPL code, when a court finally proves that that is not a problem, we will have no argument left. We need to do something more than just ask whether models have copyrights. On the whole, the easy summary to this question is, well, maybe. Maybe the model itself could have some copyright. Training the model, is that an infringement of copyright? Well, maybe. Maybe not. Is using the model an infringement of copyright? Well, probably not, but maybe. I don't want to put all of my argument there. The core issues in AI go much further than just the copyright. The biggest issue for us in the world of software freedom is the sheer volume of data. The amount of data you need to train an AI is bigger than the amount of data in Wikipedia. In fact, it's about 3 times the amount of data that is in Wikipedia. It is a truly vast amount of data, terabytes of data. And that data is extremely hard to do full copyright clearance on because there are terabytes of it. It will keep the lawyers in the room employed for the rest of eternity. Congratulations, Carlo. Then there's the models. What do we need to know about them? How do we fix things? How would it be a free model? What would an open model mean? And then there's the knowledge you need to know how to answer these questions. All of this is amazingly esoteric, amazingly difficult to work your way through. And then there's the hardware you need to run AI. There's a lot of processing involved. And then once we've got past all those practicalities, there's the questions of what it's used for. Do we want AI to decide how our children should be educated in a school? Do we want teachers putting our children's test results through an AI to work out which classes they should take next semester? Do we want our population to have its benefits and the rules for living in various parts of the town determined automatically by an AI? Saves a lot of money on police. Why not? Maybe that's a good thing. And then finally, there are the social norms of using AI. These are not even beginning to surface yet. So, two things. Great big impact, very little ability for individuals like you and me to know how to deal with the impact. So what happens in these circumstances? Well, what happens in these circumstances is that the government regulates. When there are robot cars on the streets that might kill people, the government regulates. When there are AI models being used by banks to decide who can have money, the government regulates. When AI is being used within products in the home, the government regulates. When hackers have more access to the AI model than the citizens do, the government regulates. And so that's exactly what's happening. There is something called the AI Act that is being considered at the moment in Brussels. And actually, I do have some maybe slightly good news about what's going on in Brussels, but traditionally, our community has not been in the room when regulations about these things have been discussed. So we're seeing three things that mean that action is needed now to think about what software freedom means in AI, or what an open AI is. There is the government regulating, and by government I mean every government at every level. My government in the UK decided to interfere last week. President Biden has put out an executive order. The European Parliament has a draft act it's been considering all year. There is a lot of regulation just about AI. There is a lot of confusion in the market, and there are companies that want to be gatekeepers. And if there's one thing I've learned from 25 years of open source, it is that gatekeepers are a bad thing. And then things are changing so fast. Once the basic capability exists, people find new uses for it really, really fast. Now, what can we do about this? Well, let's look at how open source came to be. Open source has got three different parts to how we created a universe of open source. One was about legal frameworks, and I would argue it was standardizing licensing that released developers to make the free software and open source revolution happen. Once you had sufficient confidence that you had permission to use the software, you used the software. And before there were standards for licensing in open source, you couldn't be completely sure you had the right to use the software unless it was under the GPL, and no business would go anywhere near the GPL. And so if you were working commercially, you probably wouldn't be able to use free software for that. It was also driven by principles. The GNU Manifesto and then the Four Freedoms lie at the heart of all open source and free software, and they guided us. We created a set of principles and a community, principled community formed around them. And then we innovated on licensing. There is now about 80 licenses that are approved by OSI. OSI is doing its best to reduce that number at the moment. These were the things we did to make open source work. So how about we try using the same sort of approach to define OpenAI? That's been OSI's objective for the last year. And what we have done is created a process to consult globally about what OpenAI would mean. That process started about a year ago with articles, blog posts, seminars, learned essays. Then this September, we started focusing in on what a definition of OpenAI would mean. And we held an in-person meeting in North America in October. And on Monday this week, we released version 0.0.3, which, as you will guess, is quite an early version, of a potential AI manifesto and AI definition. So this work is in hand, but we're a little bit behind here. Just like with cloud, we got behind and we let it get away, and now we have no hold on it. We're very worried we've left AI too long, and we've not defined what freedom means in the world of AI. So if we were going to define what OpenAI was, we've kind of distilled down the 4 freedoms and the 10 open source definition clauses. I think that open source is comfortably explained by saying that it gives users and developers the ability to decide for themselves how and where they use a technology. That is to say, it gives citizens agency. And secondly, it gives citizens agency without the need to engage any other party, without the need to buy a patent license, or to have a relationship, or to have a particular kind of training. And probably OpenAI will have the same principles underneath it. Let's skip over a little bit. It's probable that we will have something like the golden rule of the GNU Manifesto adapted to machine learning systems. We will say something like, if I like a machine learning system, I must share it with the other people who like it. Now, that's a lovely, simple phrase that's very attractive, but what it means, heaven only knows. Do I share the training data? Do I share the model? Do I share the software? Do I share all of them? If I do share all of them, how do I share all of them? If I give you a terabyte of training data and a trained model, what are you going to do with it? Will it even fit on your Raspberry Pi? Do you have enough bandwidth on your home broadband to be able to download the training data? How long will it take you to download a terabyte of training data on your home broadband connection? So I think there's still many questions left open, and that's why now is a great time to engage, because AI is already changing lives. It's already doing all of these things that I mentioned, drafting policy. It's writing code. GitHub has got an AI assistant that is being used massively around the world to write code for us. It's learnt from all that lovely source code that if you've given any code to GitHub, their terms of use have given them permission to train their AI with your code. And so uniquely among all of the people who train AIs about code, they have probably got a license. Regulation is inevitable here. There is no way that we can opt out. You can't opt out of AI regulation or open source regulation or software regulation any more than you can say to the policeman leaning through the window of your car that you are opting out of the speed limit. They are not interested. The thing governments do is make rules, and you have to follow them, even if you don't agree with them. So all of our principles that we have had in open source for many years, the text in the capitals. Have you ever looked at that text in the capital letters in open source licenses? It's there because in US law, you have to make sure that saying you take no responsibility for everything is a very noticeable statement. And the only way we could make something noticeable 40 years ago was to put it in capitals. And so that's why it's in caps. It's because you must pay attention to the fact that if you use this software, the people who wrote it take no responsibility for it. Now, there's a bit of a problem with that. because some of these new laws are going to take away your ability to waive your liability, particularly the one at the top, Cyber Resilience Act. Many of us in the room have noticed the Cyber Resilience Act this year. Quite a few people actually have been to Brussels and said that we think that there is a problem with it. Just out of curiosity, how many people here know what is in the Cyber Resilience Act? Can you give me a raised hand? Right, it's amazing. I don't know that I could have asked at a previous conference here and had people say they had read a European Union bill. Something is changing. So the Cyber Resilience Act is a significant, substantial piece of work. And yet, it was drafted without any of us in the room. The people who wrote it didn't come and ask me. And I represent the Open Source Initiative. They didn't come and ask Matthias, and he represents FSFE. They didn't come and ask Eclipse. They didn't come and ask the Linux Foundation. None of us were advised that it was in preparation. The first we found out was in January, when the final text was passed from the European Commission to the Parliament. So something has got to be changed there. We are part of something I call the fourth sector. That is citizens with the freedom to play the roles of businesses. And the fourth sector has been completely absent from all of that regulation. So there's a list there for you of regulation. None of those, I think, has had any input from any of our organizations. If I'm wrong, come and tell me afterwards. If they talk to you, can you come and tell me? Or Alexander, wherever Alex is going to be on the panel later. Come and tell one of us if they came and asked you, because they certainly didn't come and ask us. And it's our job. So these acts up here are of varying impact on free software. The CRA is going to make software subject to regulator-supervised liability. The Product Liability Directive update is an update to the existing product liability that is going to make consumers able to claim damages from people who write bad software. Let that just sink in. They're going to be able to claim damages from people who make available on the market software that is knowingly defective. The Digital Markets Act is already on the books, and the Digital Services Act too. Those, generally speaking, do good things for free software. They're opening up chat interoperability, for example, and they are opening up app stores. The AI Act, we've talked a little bit about, and I think there is a talk about it today from somebody I saw on the agenda. And that has a matching liability directive. Interoperable Europe Act, that's good news for free software, I think. And Lena, is Lena here somewhere? Lena is doing a talk about that later, and you should go and listen to her talk about the Interoperable Europe Act. It is going to tell European governments that they have to have software that works across borders. And the best way to achieve that is to use free software, instead of to spend money with consultants in every individual country. There is a standard essential patent regulation, basically neutral for free software, but it is going to finally regulate the cowboy, cut-thrust, backstabbing world of standard essential patents that I spoke about at last year's conference. And more, there's more. I mean, these 10 are just the 10 that would fit on the slide. There's more coming. This wave has happened because we won, okay? We've got so much to worry about here because it worked. All the things we've been talking about at SFSCon for the last 20-something years, people took notice, and it's working. So what will software freedom mean in this new world? If it doesn't do you much good to have the source code under a free license, what does software freedom actually mean? If you need to have a relationship with a cloud provider to be able to exercise your software freedom, do you really have software freedom? If the software doesn't run on any computers you own, do you have software freedom, even if you have the source code? If the computer that you own does run the software, but you don't control it because it's got something that calls home to make sure you're not uploading kiddie porn, do you have software freedom? What does software freedom mean in this world? I suggest we're going to have to expand our thinking about what software freedom means. So at the moment, by software freedom, we basically mean that users retain agency and that intermediation is optional. That's basically what you've read all of the open source definition and the 4 freedoms and the GNU Manifesto. It all boils down to those 2 phrases, user agency and optional intermediation. Now, I think we need to add to that regulatory protection and how it works. We have regulations that respect and protect rather than forcing us to use an intermediary. Now, what do I mean by that? If you look at lots of those laws, the best way to satisfy those regulations is to not do it yourself, is to let Google do it, or to let SAP do it, or to let Hetner do it, or to let somebody else do it for you, because they can afford to employ someone to understand the regulation, and they can afford to buy insurance, and they can afford to go bankrupt when the European Union takes 10% of their turnover for failing. And I think that's wrong. I think regulations should leave us respected and protected rather than forced into relationships. And then I think that we need to focus on federated. Federated software means software that I can and probably might run myself, that talks to software that you might run yourself, but can also talk to the software that is in the center. Best example of that at the moment is Mastodon. But there are a number of other approaches based on either XMPP or ActivityPub. And I suggest that one of our rules of software freedom is it's federated first, not centralized first. But what do I know? We need to have a discussion about this. And we're late to the game. So I encourage you to get in touch if you've got ideas about this. In particular, get in touch with me on Mastodon or PixelFed or whatever your favorite ActivityPub tool is. And tell me what your thoughts are on software freedom. And then get involved in regulation. The next step with many of those 10 regulations is to transfer them into Italian law or into Austrian law or Swiss law or German law. It has to be transposed into national law in every country. And in every country, the government needs people who know what free software is. Not people who are there to advocate that they use it, just people who know what it is, to tell them how to transpose the law and keep us all free for the future. So it's 20-something years. There are 800-something of us here. We won. We have all the problems of adulthood. That's probably good, isn't it?
Thank you. Oh. Thank you, Simon, for the state of free software and software freedom in the EU and in the world, and how AI is changing the game, or we have to understand how to be part of the change itself. Now we have as our guest Frank Karliczek, who is founder and managing director of Nextcloud. Nextcloud is one of the free software platforms most of us use, if not everyone. Maybe everyone is using Nextcloud in a way, maybe he doesn't know, but some are also using it consciously. And as far as I understood, Nextcloud is facing also the request by the market, from the market, to be an AI-enabled platform, and therefore welcome to SFSCon 2023 to bring a report about someone who is developing platforms and has to implement AI now because the pressure is here. So welcome, Frank.
Thanks a lot. It's really great to be here. I was here many, many times. I have to say, last time this group was a lot smaller, so it's really amazing. So congratulations, Patrick and everybody else, to grow this event to such a nice event, getting together and with such nice people and very, very interesting talks. So of course I will talk about AI too. I didn't know that Simon also has this in his focus, but I guess it's a hot topic at the moment, so we have to talk about it. A little bit about me. I'm a developer by training. Unfortunately, no longer do this. I do stuff like this, standing on a stage, which is also fun, but developing is also fun. I'm doing open source since like end of the 90s, and free software even before that a little bit, in lots of different roles. For example, I was part of the KDE community for a long time. Then I'm helping the W3C a little bit, or no longer, but at a time, to specify the ActivityPub standard. I'm a member of Open Forum Europe, where I try to lobby for open source at the European level. There's a little bit of work with the United Nations, but I think I was mostly invited here as founder and CEO of Nextcloud. So I want to talk first a little bit about Nextcloud, but only to set the context for what I'm going to say later in the talk. Then a little bit about this ethical AI framework we developed earlier this year, about what we're doing with the Nextcloud Assistant, and at the end, a little bit about the future, what is open source AI, but again, Simon stole my thunder here a bit. Sorry for that. But maybe it's good to repeat things also. Okay, so first of all, set the stage. What is Nextcloud? What are we doing here? And why is this important? So when I founded this many years ago, Nextcloud is now 7.5 years old, previous project, 13 years, the situation was that it became clear that more and more applications and data are moving into the cloud. At the time, I was really deeply involved in the KDE project, fighting for the Linux desktop. I don't know, some of you, the older ones, might remember that we were fighting for the Linux desktop. And we had some successes. It was actually getting usable and good, got adoption. But what I saw is that a lot of people actually use only the browser to access then Gmail, which is running in the cloud, or using Dropbox to sync your files. So in a way, yes, great, Linux desktop becomes useful. On the other hand, we're using applications that are running somewhere else. So is there really the freedom there that we wanted to achieve with the Linux desktop? And then this was basically the trigger when I said, okay, we need to have free software, open source alternative to these big tech companies. What these SaaS companies mostly do in the cloud, we need to have this also as decentralized, federated, completely free and open alternatives. And this was like the trigger of everything. This is a little bit of a history slide I often use. It shows that like the file server is a bit our grandpa. The older ones might still know this, like Novell file servers, Windows file servers, NFS shares and stuff like that. Very popular in the 80s and 90s, of course. Then a little bit later came File Sync and Share. File Sync and Share is basically already the successor of it. You can have a web interface, you have mobile access, you can offline syncing and searching and tagging and so on. And the main applications are, of course, like Dropbox, OneDrive, Google Drive, and so on. But from my perspective, it was always clear that what you really want to have is collaboration software, because it's good to have access to your files everywhere, but you also want to do something with them, like edit them, view them, chat around it, video calling, conferences, mail calendar, basically everything. And this is where the major players are, of course, Microsoft 365, there's Google Workspace, and there's Nextcloud Hub as a competition. This is also why Nextcloud is structured in these four big components. There's File Sync and Share, there's with files, then there's Talk for chat and video conferencing, there's Groupware for mail, calendar, and contacts, and there's Office for editing Office documents, all under the umbrella of Nextcloud Hub. So again, some might ask, okay, great, same as Microsoft and Google, what's the difference? Well, the difference is that this is all open source and free software. And actually, we as Nextcloud, we don't host anything. Sometimes people come to us and say, where can I register? I want to use it. I'm sorry, you cannot register on our website. You can download the software, that you can do, and you can put it on a Raspberry Pi or whatever you want, and there you can register. And that's your data and your account and your service. Right? So it's all about decentralization here. So a little bit about the features. Again, don't want to do too much marketing, but it's important to set the context. This is the files interface. You have all the usual features. You can upload, download files, sort them, search them, tag them, and so on. There are mobile apps, so they're also completely free and open source mobile apps for iOS and Android, where you can access all your files from the go. They can also do offline syncing, and yeah, they're quite comparable to what you expect from a service like that. There are also like powerful security features. This is a bit more technical, but as an administrator of a Nextcloud server, you can say who can do what. For example, you can have policies where you say, people in my friends LDAP group should not be able to synchronize photos that are tagged with birthday party on a Saturday outside the local network from a device that no one knows, or whatever. Stupid example. I really need to come up with better examples, but you can imagine you can have some kind of interesting policies to avoid data leakage here. There are end-to-end encryption features. They're quite good. They also support sharing with a public-private key system. And with this end-to-end encryption, you can avoid that even the server admin or someone who hacked your server, unfortunately, maybe, hopefully not, but can really not access any data because everything is encrypted client-side. Then, of course, we also have the chat and video conferencing component, Nextcloud Talk. So this is very similar to what you know. I mean, the older ones might know IRC. And then, of course, it was later reinvented as Slack. Nowadays, we have Teams and other applications. So this is just a powerful group chat application. You can share all your documents, your maps, your polls, everything in there, collaborate with it. Very nice and powerful. Again, this is all self-hosted. You can really keep it on your device. Nothing is leaving your server. Pressing a button, you can start a video call. And again, also from the mobile and with screen sharing and everything you expect. Again, one of the very, very few solutions that are completely offline, decentralized on your machine. And of course, there are also mobile apps for it, for iOS and Android, where you can get chat notifications and you get a call screen if someone calls you, just like a normal phone call. But again, no bit is leaving your internal network if you don't want to. And there's even a new desktop client for Mac, Windows, and Linux, where you can do everything on the desktop client if you don't like to work in the browser. Then there is a calendar, of course, a powerful calendar to manage your appointments, and with other people that can be shared, everything you expect. There's even some interoperability features, like an integration into Exchange. So if you still in your organization use an Exchange server, unfortunately, lots of you still do it, so you can connect to it. There's a mail client with all the nice features like end-to-end encryption with SMIME and GPG, newsletter, unsubscribe support, priority inbox, and all the things you expect. Last component is Nextcloud Office. This is something that's based on LibreOffice, where you can manage your text documents in your browser, and again, collaboratively, so you can share it with other people, and then you have several cursors working in the same document at the same time. And this also works with spreadsheets and with presentations and everything you expect. Something that is really a focus for us is integration. So all these different tools are heavily integrated with each other. For example, here you can see that you have a document open where several people work in the same document while being in a video call, while having a chat open to discuss who is working in which area of the document. So this is quite nice. So this is what we do. I think we are the open source alternative to Microsoft and Google here. This is what we developed the last 7, 8 years. We have tons of happy users. Lots of them are in this room. This is basically the status. End of last year, life was good. Everything is great. And then came AI. Of course, you all remember that. There was ChatGPT, a little bit before that, DALL-E, and all these other services. And this was really interesting because, I don't know, I think I personally got a little bit of depression at the time, mostly because of two things. The first thing is, great, so big tech are doing features that we as free software open source community cannot compete with. because at the time there was the thinking that, okay, you really need gigantic clusters for that, gigantic data, like nothing like a normal hacker at home can do, or even we as a company. And the second headache was, of course, is this even ethical, what's happening there? Right? I mean, is this even something that, because as I said, Nextcloud was developed for reasons. It was not just random. We really wanted to have this alternative, this decentralized open source. It gives people freedom, it gives people control. How does this work with AI? Is there something we can actually do there, or have we lost now altogether? Because AI is something, I don't think it will go away. It's actually very useful. Right? It has the opportunity, the potential to help us to automate boring things, to make us more productive. It really has the potential to be really nice and useful. But obviously, there's also the dark side of AI. Right? It comes with a ton of problems, and it's really the question: what can we do here? And by the way, the problems are not only like my opinion. It also is the opinion of lots of other people. For example, you might know that Samsung blocked ChatGPT, Apple blocked ChatGPT, Goldman Sachs, and so on, many, many companies. And of course, the question is, why is that? There are actually lots of reasons for it. First of all, there's the problem with bias and with like wrong answers there. So it actually can be problematic there if you really use it like in your daily work. And the second is all these concerns about security and privacy. And I find this actually a bit interesting, because I'm saying this for 10 years. You should not give your data to some other company. I should keep it protected. But here, again, it becomes obvious that if some employees of some big companies, they're pasting their internal documents into ChatGPT, and then it's just leaking somewhere else. And it's a bit more complicated than that even, because you might think, well, then we just have some kind of data exchange agreement with OpenAI and all is good. Okay, this might then protect actually this data, but OpenAI is using your data to train the model of the future. So it is possible if someone from, I don't know, Airbus is posting some confidential data in there to get some analysis, and this is then used for training data, and later Boeing is also using the same system and getting actually answers based on the data from Airbus. And so this is actually a bit really complicated, and there's really big privacy concern. And this is why this is really critical by a lot of companies, and they're blocked the use of it. So this really brought us in a bit of a stupid, weird, complicated dilemma, because we want to produce good software. We really want to produce nice open source free software that's useful for everybody. But again, we want to do this in an ethical way. And for that, we decided that we needed some kind of framework for that. At the time, again, we call it the Ethical AI Framework. I have high hopes that this can actually be merged in this open source AI definition that the OSI is working on. But at the time, the discussion did not exist, so we created our own framework for now. So first, what we did is, okay, what are the actual potential problems? It was not so easy and not so hard to find, because you only need to open a newspaper and everybody was writing about the problems of your AI. So the first is, of course, the whole question about discrimination. Right? There is like, the AI systems are trained on data, usually the internet. And it's using just what's on the internet for training data. For example, Reddit is famously used for training of lots of those models. And as we know, well, Reddit, for example, is mostly used by, I don't know, white men in their 20s or something like that. So this is also what's then reflected in the training data. For example, if you ask DALL-E to generate a photo of a doctor, it's probably an old white man. Right? So there's a lot of bias in there. There's a lot of discrimination in there. So this is obviously a problem. Second problem is the CO2 footprint. Right? We all know this huge server farms with huge GPU clusters, and obviously the CO2 footprint, the energy consumption is really a problem here. The next one is privacy. I already talked about that. Obviously, a big concern here. Then the question is also, is this actually freely available? Right? I mean, this is also something that's often forgotten. One of the benefits of free software open source is that it also enables people with less resources to have access to great technology. Right? And who can use this system? The only people who can afford a Microsoft or Google-like subscription or something? Or is this actually really freely available for everybody? So what we did then is that we created this ethical AI framework. We came up with 3 requirements. The code should be freely available, open source, obviously. The model should be available, and the training data should be available. And we created this traffic light system where you get a green if all 3s are checked, and a red if none of it is checked. Okay. So why is this important? Let's first start with the code. Only if the source code is available, and with source code I mean the source code that's used for training, and also the source code that's used for interfering with a model, which means using a model. So both obviously needs to be open source, because only then you obviously can run it yourself, you can see what's going on, and you can also measure then and optimize the energy consumption. That's something you cannot do with ChatGPT. You don't even know what's going on. You can ask them, they'll get an answer. So open source is the first requirement. Second is the model needs to be freely available, because only then you can run it locally, obviously. You of course know that something like, I don't know, the Falcon model is freely available, while GPT-4 is not. So this is of course a requirement. And the third is the training data should be freely available, because only then you can actually look inside and you can see where all this information is based on. You can see if there's bias in there, and if there's a problem in the training data, you actually have the opportunity to fix it and to improve it and to move forward. So in Nextcloud, for every feature we developed, we have these settings where you give people a choice. For example, the first feature we have here on top is translation. So we implemented translation features in Nextcloud where you can translate texts. And as an administrator, you can choose how this works. For example, here on top you can see, if you really want to, you can use ChatGPT to translate text. Obviously, then your text is sent over there. Maybe not a good idea, but if you want to, you can. Or you can select the second option, which is the Opus model developed by the University of Helsinki, which provides a completely locally running, in our definition, completely ethical translation system. And the same with all other features. For example, the speech-to-text, you can decide to use like a hosted Whisper service by OpenAI, or you can also run it completely local, which gives you all the benefits, and the same for text processing and anything else. So giving people a choice, that's great. But of course, what we really want is this ethical AI, this open source AI, and this is what we are focusing on. So what we actually did, beginning of the year, after I've overcome my depression, I decided, okay, we cannot give up, right? We need to do something. So we formed a dedicated AI team at Nextcloud, but obviously there is a huge community out there of lots of other researchers and organizations doing stuff, and there are a lot of people collaborating, and the good news is that it is actually possible to compete. This is like the long story arc here that we have. Like 1.5 years ago, we all thought this AI stuff is magic. It's not possible. That's like science fiction. Then a year ago, ChatGPT came along, but like, oh wow, it is actually possible, but only big tech can do it. And then half a year ago, we all realized, well, the open source community can actually contribute here. We can actually do something here. There are actually opportunities. So we actually were able to develop the Nextcloud Assistant. So this is a large language model-based assistant, which is 100% open source and runs 100% on your machine. And it actually has a lot of these features that you also see from the big tech companies. For example, you can have face and object recognition in your photos that you upload. You can have a translation feature. You can have call transcript, dictations, and many, many other things. Again, 100% local and open source and transparent. And I will go into a bit more detail here how this actually looks. So on top of the latest Nextcloud, there is this assistant button. If you click on it, you get a dialogue like that, where you can just chat with the assistant, and you can do all kinds of text processing and other things you expect. But of course, the really cool thing is, once you use it integrated into the rest of the applications. For example, in the Mail app, if you want to write a mail, you can ask the assistant to draft a mail for you. For example, here, can you please send me generate an email invitation for me? And then after pressing a button, it can generate an email for you. So that's nicely integrated. Or if you work with some other text, in any place in Nextcloud where you work with text, you can mark it. Then you can invoke this menu on the side. and you can say, can you summarize it, make it longer, translate a different language, reformulate it, do anything else with it. Again, open source running on your server. Then, of course, if you work with bigger text documents, for example, in Nextcloud Office, you can say, hey, I want to have a draft of an employment contract, and you can generate a contract and inserting into the text processing. Very useful. Then let's say you're in a chat conversation and you're discussing something. I don't know, you're in a marketing group and you're discussing, or design group, do some brainstorming. Then you can say, hey, I want to generate a photo. I want to do some bracelet for something, I don't know. And then it generates a photo and inserts directly into the chat, and everybody can look at it and discuss it and build on top of that. That's, of course, again, very useful. Some people want to dictate their emails or their texts or their documents or something, and I'm also happy to say that we have a dictation system built in now based on Whisper, which works completely local on your machine, open source with publicly available training data. This speech-to-text system is also very useful in other places. For example, if you do a video call, at the end of a video call, we always get a transcript of the video call, which can also be automatically summarized if you want that and shared with everybody. Again, very useful. And I really think we are the only ones in the world who can actually do that completely local. All other solutions like Zoom and Teams and so on obviously need to send your internal conversations to the other side of the planet. And this is, I think we're the only ones who can do this completely local. Then the assistant can also be called in other places, for example, in the chat. Let's say you're in a chat conversation at the moment and you're planning an event. Maybe you're planning this event here. And then you can say, hey, what are the most important things that you need to take care of? And then the assistant writes you back like a real human assistant, right? Gives you back the answers directly in the conversation, and you can keep on working with that. So that's very useful. In email, you can say, wow, I get so many emails. There's a long email thread about some brainstorming. I don't have time to read everything. There's a way to get a summary of an email thread on top of the email list. That's also very useful. And this, of course, additionally to the priority inbox that we have on the site, where it already learns and decides which mails are especially important for me. Then some more technical things. This is a feature that analyzes the login behavior of every user into Nextcloud. And if someone logs in the middle of the night from a different continent, then maybe something is wrong. And it can trigger two-factor authentication or send you a warning. This is also based on a locally running neural network. And last but not least, it can do document classification. So if you upload documents and you can say, okay, this document contains bank information, social security information, or some other things, and you can then tag the documents and say, okay, these documents are confidential, they cannot leak the organization, for example. So, of course, not all these features we really completely developed our own. Lots of it is a collaboration with lots of other open source initiatives and organizations. So this is, again, the power of open source. And for that, we developed a new microservices API, which makes it possible to integrate all these other tools. For example, most of Nextcloud is written in PHP. Lots of machine learning stuff nowadays is in Python. So we have this new API that makes it possible to integrate it all together. I'm running a little bit short on time, but that's okay, because I'm repeating what Simon said anyway now. So this is the last part of my talk. What we really need is a clear definition of what open source and ethical AI actually means. So this is basically the proposal from the Nextcloud community to focus on those three things to achieve what we want, but it's an ongoing process with the OSI. So I think very helpful, again, to look at the 4 freedoms. These are the 4 freedoms from the Free Software Foundation. There's also the open source definition, but for now I use them as synonyms. If you look at the 4 freedoms, it means that everybody should be able to run the software as they wish. So what does it mean for AI? Use the software as I wish? Well, then it probably should be able to run on my machine and not as a SaaS service. Right? It should be local. The second is to study how the program works. Okay, how can I study how an AI system works? Well, obviously, I need to have all the components. I think you need to have the source code that trains the data and that uses the data, and I really need to have the training data This is a bit of a controversial discussion in this community, but I think you need to have access to the training data to really be able to study the system. Otherwise, it's a black box, right? In a way, the training data is the source code and the model is the binary, in a way, you could say. And then, of course, the freedom to redistribute everything and also the freedom to redistribute your improved version of it. Again, this requires proper licenses. In the case of software, obviously OSI certified licenses. But for the training data, this is a bit more unclear. I'm not a lawyer, but maybe something like Creative Commons gives you the freedom to access the data and distribute it further. So the summary, from my perspective, is that ethical and open source AI is possible. Again, that's a learning for me. I didn't believe in that a year ago, but it is possible. It can run locally. You don't need gigantic server farms. All the stuff I showed you actually could work on a Raspberry Pi if you want. Not crazy fast, but it works. And if you have a little bit of a better server, maybe with a GPU in it, it's actually quite fast and totally fine. The second is, there is a way to measure the CO2 footprint of all these systems. Again, it requires access to all the components, but I think it is possible to measure it and to improve it over time. And I think it's possible to minimize bias in AI systems, but it requires access to the training data. Otherwise, you have no chance. So I really think that an evolved open source definition for AI is needed, because this is not going away. This is not going away. And as Simon said, this is used for self-driving cars and for all kinds of other critical things that it can actually kill people. So this is nothing we can ignore. We cannot ignore that. We need to get on top of it and make sure that it all goes into the right direction. Thanks a lot.
Thank you, Frank. We will keep you on stage because the next session is a discussion round, and I invite Simon Phipps on stage for the moderation. We will get some chairs. Also, Carlo Piana from Array and president of OSI is joining us, and Alexander Sander from the Free Software Foundation Europe is joining us as well. So, I have to say I'm really thankful to Frank, because Frank, after the talk of Simon, I was a little bit worried about, but Frank has brought hope.
Yes.
So I'm looking forward to your discussion panel.
Thank you.
Floor is yours.
Thanks, Patrick. Well. So really my first easy question is for Frank. When you say it's not crazy fast on a Raspberry Pi, what do you mean? Are we talking hours, days, weeks? Yes. Water cooling?
It depends. There are some things like the share recommendations, the priority inbox, the face recognition and object recognition. This is like, I don't know, 2-3 seconds, so that's super fast. Other things is like, I don't know, generate a complicated image with stable diffusion. That could actually take something like an hour.
Right.
If you have a GPU and a good server, it takes 5 seconds, so yeah. Okay,
so now proper questions now. During my talk, I suggested that a summary of the free software definition and the open source definition is to say that we agree that users and developers need agency and that they need independence. Those are the two things we've spent 40 years building communities and a changed world around. What do you think are the one or two new principles that we need to add to the free software definition and the open source definition in order to accommodate AI and cloud and Bitcoin and the other systems that we've seen impacting our world? And can I start? I'll start with Alex, because, so let me introduce people here. So we've got Alex Sander. Alex and I work frequently together, despite the fact that he works for FSFE and I work for OSI. but we're happy to eat together and work together. So
Crazy.
the world has changed. Crazy stuff, isn't it? And he works on public policy, and so do I work on public policy. Alex, what do you think, what's your favorite new clause for the free software definition?
I liked your slide where you have shown like the path to AI, where you end up in prison. And I think data is key, and it's also what we learned from Frank. And I think that's the most challenging and most important part is how do we get the data and how we do process this data. And I mean, we have a data protection, or we had a data protection reform, and we talked about privacy a lot, and it's popping up again when we talk about AI. A bit differently, to be honest, in this debate, but I think this is definitely what we need to further discuss. And I mean, we had some ideas on like open data, for example, but weather data, whatever. So this is, I think that's fine, that's clear, but it's in particular about the private data or data that should be handled a bit more careful than just pushing it to the Googles of the world, and that's something we should have in mind when we talk about AI.
And then let's bring Carlo Piana in. I think a lot of people here know Carlo, but Carlo is my boss now, because he's the chairman of the Open Source Initiative as of 2 months ago. And he's also your best lawyer in Italy, possibly in Europe. So, and he also doesn't like me saying that. Carlo, do you think there is any principle that we can live by that is going to save us from big tech owning AI?
Of course, if you ask a lawyer, and the answer is always, it depends. So, even in this context, it depends. So it depends whether you're running your own AI or you are relying entirely or in part to services to an AI made by somebody else and run by somebody else. I think that if you're running your own AI or are trying to replicate an AI on your own machines, the basic freedoms of the 4 freedoms, I think, don't need to be expanded very much. Conversely, if they are run by other people and you're relying some way on something made and run by others, then there's a lot of things that needs to be added. And privacy has been mentioned, and it's a right to people, right to user, and not just to user, but all the other people who are involved, whose information are involved, whose decision the decision impact them. These are considerations that need not to be enshrined in a definition, but it must be made by public policy, by government intervention, and yeah, this is my take.
So I think there's going to be a lot of regulation around. Frank, are you worried about all the regulation that's coming in your business? Is it something that a free software business can survive, do you think?
Well, the question is, of course, what kind of regulation? In general, I have to say that I'm really in favor of it. So as you said, it's early in your talk, it's technology that can be dangerous, and we have regulations who can drive a car and who can have a gun and who can get drugs and lots of other dangerous things, and that's dangerous here and needs to be regulated. But again, also as you said, we need to get involved. That's important to make sure that it goes in the right direction. With the Cyber Resilience Act, you can see how easily it can go intentionally or not intentionally go in the wrong directions for us.
Yes. So, I mean, we saw that happening on the Cyber Resilience Act. Alex, how did you feel the European Commission did at accommodating free software in the Cyber Resilience Act? What was your impression?
I mean, first of all, they recognized that they have to regulate open source in a different way than proprietary software, and that's a major step. I couldn't expect something like this 10 years ago. So, and that's the first thing what we also have to acknowledge, that there is progress also in policy. However, as you also said, they never asked us beforehand, so that's why we have to fix afterwards a lot. But this is, I think as long as we are capable to fix it, then it's in the end, if the result is there, I can live with it. And I would say, for example, the European Parliament is very, very open to our arguments, and they are very happy to learn about it. Same is true for some member states or some council members. And this leads to the situation that also Commission learns a lot on this way, and they already learned a lot on this way in the last year. And from what I hear and feel is that they are also open to change what they drafted in the very beginning. And I do have the feeling that after the Cyber Resilience Act, the next laws they might draft, they might come up with a better wording. And it helped a lot that we stepped in and that we came up with our arguments, and that we also not ask for like a complete open source exclusion or something like that. So, but we have been very precise on what's the difference between a foundation having, I don't know, a budget of 10 million euro, or an NGO, or a company, or a micro enterprise, and how the open source development process looks like, where the money is involved, and which parts the money is, and where liability should be placed. And in this regard, so I'd say, to sum it up, so it was definitely not the very best proposal we have seen, and the Commission could have done better, but I think they learned a lot in the last year.
And at least the guy who wrote the CRA came to FOSDEM and stood in front of the audience and admitted to writing it. I thought that was a thoroughly good thing. Now, I gather the Commission are very keen to come to FOSDEM again this year. So I think we're going to see a lot more regulators. So if you're coming to FOSDEM, look out for regulators. Make friends with them. Be nice to them. Benjamin, who wrote the CRA, asked me if he comes to FOSDEM again this year, are people allowed to throw tomatoes? He asked. In the context of all this, Frank, you know, you've been doing Nextcloud and the other thing for a long time now. Is Linux on the desktop dead? No, have we got to take software freedom beyond the idea of personal software running on personal computers? Which is what I mean by that. Is the desktop finally dead?
That's an unexpected question.
Yes. That's how I roll.
I don't think the Linux desktop is dead. I mean, the latest numbers actually show like the highest percentages ever. Still very small, but it's growing. But I think the important thing is that at a time like the 90s and beginning of the 2000s, like everything was on the desktop. So the desktop was everything. And now we have, of course, the cloud, and we have smartphones, and now we have the AI, which also has, I don't know, data in it or not, I don't know. And now the picture is just a lot bigger. So yeah, now we're in a good position that we not only have to fight for the Linux desktop, we have also fought for the Linux cloud and the Linux AI. No, this doesn't make sense. No, but I mean, yeah, just the challenge got bigger.
I have a comment on this. I always wonder why, anytime I see people from the Linux Foundation using a computer, is invariably a Mac, which is seemingly, it's counterintuitive. It's a question I would like to ask, and I've asked many times.
Yeah, and did you get an answer?
Yes.
Yeah. And do you dare share it?
No.
No, I didn't think so. Something about just working, I think. So yes. So if we're going to have to expand our definition, what do you think we need for user agency in the cloud? Because I run Nextcloud on a server at home. I don't think there's anyone else in my family who would even think of doing so. Do you think we've got what it takes to give individuals agency on the cloud now?
No.
I'll let you answer first, Frank, because it's really...
No, of course
Carla
not.
has a view too, I think.
No, I mean, we're doing the software not for ourselves, we're doing it for the whole world. And then you need to check what the whole world is using. And if the whole world is using Microsoft and Google and other stuff, then we're not there yet. So there's a lot to do.
Okay, unlike software, traditional software, where you only need access to source code when source code is not available, for replicating the same kind of freedom in AI, you need a lot more. It's been said before. You need software, you need data, the model, and you need training data, i.e., what has been used to train. And this is quite tricky because that's heavily dependent on copyright. So if the training data has been taken from commons and they can be freely shared, you can share them. If they're taken from publicly available and usable for training, you cannot share them. So you can point to them, but it's not guaranteed that you can replicate. So reproducibility, even if it's possible at all in AI, it's impaired by the existing definition and the existing rule of copyright, for instance. And I may add something. The knee-jerk reaction of people when they're using my stuff to train data is to create another IP. Or to expand existing IP. So you're creating exactly the opposite of what is needed because you are creating friction, and so more and more small entities will be able to replicate because not just they don't have the money to run the big computer, but they don't have the money to resist to copyright claims, to reduce because in the frictionless environment, everybody is enabled to compete. In a friction environment, only the big have the energy to survive.
So this fascinates me because the idea for me of free and open source software was to create a massive commons where all the software was available to everybody and where I could do what I wanted with it. It was actually there in all the definitions that I could do what I wanted with it. And yet our reaction to seeing Microsoft using all of that code that is freely available to everybody to train their AI model has been, hell no, you can't do that. Isn't that a contradiction? I mean, Alex, isn't that a contradiction? Surely, if it's a commons, it should be something I can use for everything.
Sure. So I mean, if it's free for everyone, then it's also free for Microsoft. So that's part of the game. So and it's on us to see what we can do better, maybe. And coming back maybe to this cloud issue and the Linux desktop. I mean, our own community, not the FSFE, but our open source community, whatever, is also happily sharing Google Docs, for example. And I have no clue why. So why are these people doing this? So why does the open source community is sharing Google Docs? I have no clue. So, but this is actually what we are doing. So, and this is also then how we end up that Microsoft does stuff like this.
I'm going to let you answer. After this, I'm going to look for some questions from the audience. So if you'd like to ask a question, think about how you might ask that question, and we'll bring a microphone down to you, or I will, or Patrick will. Yeah. Okay, back. Sorry.
Yeah. I mean, the answer is, of course, that a lot of people don't really think about it and don't think it's a problem, and it's just some tools and use it, and who cares? I was like, last weekend, I was at the Ubuntu Summit in Riga. I was actually sitting on a very similar panel about very similar topic. But last weekend, there was not Carlo next to me, but a guy from Microsoft.
Thank you.
and he argued, like, yeah, AI is great, it's useful, it's cool, it's fun, just use it. What's the problem? And that's, of course, the interest of these companies, right? I don't want that you think about ethics and software freedom and citizen rights and stuff. That's just like, oh, it's just a product and use it and don't think about it. That's a problem.
Well, thank you very much. Okay, so we've talked about AI, we've talked about software freedom and what it means in a world of enormous data and cloud computing. Do you have any questions? I've got a question in the center there. And if you can wait for the microphone so that people listening in other places and other times are able to hear your question.
I have a question. This is a question that I am posing since quite a lot about the term artificial intelligence. In your slide, Simon, you used what, in my opinion, is the correct term. In one slide was ML, which stands for machine learning. So I want to understand who was the man who posed the terminology intelligence attached to a machine, which means people is thinking, okay, this is intelligence, so it's something that's very human, is more acceptable, and it's a mistake, I think. It's something that I pose like a criminal, intentional idea to make people thinking that it's more acceptable. Machine learning is something very precise, is an engineering terms, and is so bounded. The artificial intelligence, if we will talk as a criminal intelligence attached to a man who is in prison and is a criminal, it will be acceptable. Is attached to a person, to a human being. But artificial intelligence, where comes from, and I am against, really strong against of the usage of this term. And I am trying to let it stay and use machine learning instead. What about?
Yes. So I don't think that the term AI is universally a good thing, because, I mean, Skynet in Terminator was an AI. HAL was an AI in 2001. I think that AI actually has sinister overtones to anybody who has read a book or seen a movie. So I don't think it's an absolute marketing win as a term. But in our community, we have decided to fight wars over terminology in the past, and we haven't got a good track record of winning. So while I prefer to talk about statistical models and machine learning, I am unstoppably presented with people talking about artificial intelligence, to whom I normally respond, oh, you mean Terminator? Anyway, what do you think, Frank?
Yeah, so it's a stupid marketing term, of course, and it's unfortunately really hard to fight it because it's so widespread now. And you could say, well, it's just a marketing term, who cares? But I think there's actually a problem, and you pointed this out, that yes, Terminator, AI, evil, hell, all these other examples, they may be evil, but the thing is they're all quite intelligent. And if people hear AI, they think maybe it's, I don't know, has ethical problem, but it's actually quite intelligent. And no one considers that they actually might be stupid. And then it can make mistakes, and lots of mistakes, and maybe a lot more mistakes than humans. And then if you then trust the systems to decide who goes to jail or not, or about a self-driving car, no one considers that it might be not good with it, because you think about Terminator, who can ride a bike. Yeah.
Yeah, I think that attaching the idea that a machine can be intelligent is equally preposterous as attaching the idea that this applies also to humans, actually.
Yes.
Some humans, yes, some no.
Alex?
I'm not sure if this, yeah. So I mean, I'm using mainly this term as it is used by legislators, and it's good to go with their wording. And I also have sometimes the feeling that what they want to regulate is not what's out there now, but what will be there in 10 years. And that's why it might be good or bad to go with this term. But it's the way we do law now, and that's why I'm using this term.
Jolly good. Okay, so we have another question. So this is Karen Sandler from Software Freedom Conservancy, who is speaking later. So Karen.
Thanks, Simon. I just wanted to ask a follow-up question about what was talked about earlier. When we raised the fact that why do we have any objection to Microsoft using our code now, I mean, I think that if we look back to one of the most important innovations of free and open source software is copyleft. It's the idea that anyone can use the code so long as they do so and follow the rules, right? They do so on the same terms. And given that we have seen these models outputting code that has to be single-cased, excluded to not produce copylefted code, and to, in fact, not produce the GPL in full. I was wondering what you all thought about that, like sort of what you thought about copyleft in this model and whether you had a different answer.
My hunch is that Carlo is most likely to have an answer to that question.
That's a hell of a question. I think that on the one side, this is a sign that we have won to some extent, because there is a lot of commons that can be used, even by Microsoft. For which purpose, for which use, for which level of freedom, that remains to be seen. And I think we should work to be on a part of that, so to develop the similar technology, similar to be, not to rely on a single broker of this kind of innovation, but to have many who can compete. And I think that creating the space for competition and understanding how competition can work even in a platform economy, that's the best solution for me. We must forget what we have done, we have achieved with copyleft, because this is not going to be available anymore. We need to devise new ways to ensure that freedom is preserved. And this can be policy, this can be users' rights, it can be anything. But please don't suggest that we need more IP to resolve this issue, because that's the wrong answer.
Yeah, I mean, it's in the end, it's a copyright issue, and if you use GPL code to train your language model, then the outcome should be GPL. If not, it's a copyright thing.
As copyright works, in order to control a derivative, it must be a derivative. In order to control what is put another way, you have the freedom to study the code, and the freedom to study the code means also the freedom to imitate, to create a new, different implementation. And this is what an AI is basically, a machine learning, or what you call a generative system will produce. If it's not the same and it's different, but it's learned from you, that's a success. It's not a failure of copyleft. But if you try to say that copyleft has a bearing on something which is not a copyright derivative, which is a somewhat well understood concept, or, I mean, many understand it, but everybody understands it differently, but that's another matter. If you're trying to suggest that it can have a reach outside what is considered copyrighted derivative under current laws, or to expand to have a reach on something which has been created by observing and replicating using the same same models, that is going to be a huge problem. You're creating more problems than the ones you're trying to solve.
I think we have another question. We've got 4 minutes left, and we have 2 questions down here. What is your question, sir?
Hey, first of all, great panel. Really enjoyed the discussion. My name's Hobie Wedler from California, and I happen to be totally blind and fully use AI now more than ever to decipher images for me. I happen to be a blind scientist as well as entrepreneur, so looking at a chemical structure, AI is very helpful in telling me what's going on. One of the things that I'm faced with, and this is sort of a philosophical question, is if AI is going to be used for driving cars like it already is, and I'm a pedestrian at the mercy of drivers to stay alive, and I'm a pedestrian for obvious reasons, How can we ensure in the next generation of AI that everything that we're doing is strong enough and tested enough and iterative enough that we trust it to a point that we allow it in public places? And how can we maintain the fact that AI as a whole is used for ultimately enhancing and increasing that quality of life rather than detracting from it, and ultimately make sure that AI is used for good and not less than good?
Thank you. Frank?
Yeah, I mean, very related to the question earlier, this is a bit of the problem with the term AI, because it contains intelligence, so everybody assumes, oh, it's intelligent, it's obviously a very good car driver, and it will not kill me because it has it in the name, right? So it must be true. So we must consider that there is maybe, beside artificial intelligence, there might also be artificial stupidity. Right? Maybe it's also to propose this as an alternative term. And same with other things. We need to check where something is between the AI and the AS scale in between. For example, if you have a lawyer and a judge who decides if someone goes to jail, then this is obviously a person who is highly educated and tested and went through a huge process until like the person has then the power to do these big decisions. And maybe with this kind of machine systems, we also need some kind of process where we then decide if the car has artificial stupidity or artificial intelligence built in. And that again goes back to the regulation part. I think this is part of the regulation to make this clear.
Okay, robust, reliable. How do you make sure that this is true? I think that with software, having access to source code and having it modifiable, especially in medical devices. Karen had a huge and a very great battle to have all medical devices being open source, some way at least. With AI, this is not sufficient, and you must make it inspectable. You must make it explainable. You must make it somewhat. There is a. It's not. We must have the equivalent of deposing a source code to public records for further inspection. This is the same level of protection we need to have if we must rely on something that somebody else has made, or it has made itself by itself.
20 seconds, I'd say it's a question for the Liability Act for AI.
Yeah, I think it is. So we have 18 seconds left here.
So maybe we can ask people to join this debate.
So maybe you could ask your question very quickly.
Then I would yield my time, basically, and just say, there's going to be another place for my question.
Okay, all of these people and people over there, like Karen, are freely available throughout the conference to ask questions to and have conversations. And I think your session is on this subject, isn't it, Karen? Yes. So Karen is one of your global experts on how copyleft affects AI models. So I should talk to her as well. So thank you very much. I think what we've discovered here is that there are a lot of questions and that answers are hard to come by. We are at that stage with understanding how to refactor software freedom so that we end up with agency and independence in a world of AI and cloud, where we need to work on it, where no one is coming to the conference with ready-to-use answers. And so that means this is an opportunity for everyone here also to contribute and to make a difference. Thank you very much for your time and attention, and I hope you find the rest of SFSCon at least as good as the things that we've been able to talk about.
Thank you very much, Simon. Thank you all the panel attendees. Now we are going to the very nice part during SFSCon, which is we give an award. So, SFSCon has grown from a local event, a local conference with some attendees, to at least a Europe-wide conference, a Europe-wide recognized conference. And with the SFSCon, with the attendees of the SFSCon, also the content has grown. So some people are leaving, some are joining. Let's wait a little bit, otherwise I have to shout. A lot of discussions after AI. See, the topic is of huge interest. Okay, so please take a seat. Then we can start with the European SFS Award. Since this year, we decided to expand the award given during the SFSCon to be a European prize. We will not choose only locally, but we had a long process of selecting from a lot of nominees. We had a nomination deadline, which has been filled up with a lot of very important people contributing to software freedom in Europe and in the world, I would say, and also has an implication also for Bolzano, of course, because we are in the center of Europe. And the Linux user group of Bolzano has joined together with an European organization, joined together with the Free Software Foundation Europe to create the European SFS Award. And now I invite on stage the president of the Linux user group of Bolzano together with the president of the Free Software Foundation Europe. Okay, sorry, I did a mistake. It's not the president of the Linux user group of Bolzano, but vice president.
I'm in the board of the Linux user group, and yeah.
Sorry, I'm not up to date of the last elections, but congratulations for joining the board of the Linux user group of Bolzano, Rafael Barbieri, together with the president of the Free Software Foundation Europe, Matthias Kirschner. The floor is yours to announce the winner of the European SFS Award for 2023.
So thank you, Patrick, for the quick introduction to the European SFS Award. And it's also an honor for me to be a part, in behalf of the Linux user group, to be a part for the first European SFS Award, by continuing a 20-year-old tradition since the first SFS Award was assigned to Hugo Leiter in 2004 for introducing LibreOffice in all municipal places of South Tyrol. And this tradition will continue. And yeah, since the award was also always given to someone who traditionally, yeah, let's say, contributed to the culture of free software in South Tyrol. But as the SFSCon this year, we extended our field and narrative to an essential European level, and looked at that promoting digital sustainability in South Tyrol, and joined forces an important association active in the sphere of Europe of free software, namely the Free Software Foundation Europe. And let me introduce the president, Matthias Kirschner.
Yeah, thank you very much, Rafael. Thank you all for being here. I mean, as FSFE, we have participated here at SFSCon for a very long time already. And we always saw that Luc Bisset was awarding great free software contributors in Italy here. And so we have been very happy to be approached to join forces and award a European free software contributors together with Luc Bisset this year.
And as in the previous years, we received many nominations for potential winners, and it was not easy for us to choose a winner, since many of the suggested candidates made an enormous contribution to free software.
So the deciding factor for us this year was to choose a European who lives the values of software freedom. A person who has dedicated decades of work to software freedom and brought it to the next level. True visionary and a pioneer of software freedom.
And in 2001, over 2 decades ago, he started kde-look.org, later gnome-look.org, as well as opendesktop.org to improve free software, and supported many initiatives in our field, including as a vice president of the KDE EV. In 2010, at Academy, he laid the foundation for a platform that enabled millions of people to store their data securely and self-determined on servers. He promoted open standards and inspired people to join the movement for software freedom. With the development of a remote collaboration platform for teams, which is developed under the Freedom Protecting GNU AGPL license, he followed his ideas and his strong belief that users should have the right to use, understand, share, and improve their software. That created a comprehensive, user-friendly, and secure platform for collaboration.
His tireless commitment to software freedom has resulted in a free software product which some of the biggest technology companies around the world fear as a competitor. Even in situations when he could have personally or with his company benefited financially, he decided to follow his principles and ensure that there is a fair, level playing field for all of the others in our community.
He's not a gifted technologist, but he's also a champion of the idea of digital freedom as a universal right. With his work, he believes the idea of transparency, privacy, and individual control over digital information. But he's also laid the foundation of a diverse and engaged community.
His dedication, his vision, and his strong principles enriched and inspired many in our community. We are deeply grateful for his contributions, and we look forward to a future he helps to shape. For those reasons, we hereby award Frank Karliczek, founder of Nextcloud, the European SFS Award 2023.
Thanks a lot. Thanks a lot. This is really mind-blowing. But I have to say that I can accept this award only in the name of the whole Nextcloud community, because Nextcloud is done by a community of thousands of people from all over the world. These are the people who are doing the actual work. My contribution nowadays is usually standing on stages like that, which is not as important as actually doing the work, writing the software. But yes, I accept the award in the name of the whole Nextcloud team and community. Thanks a lot for the honor.
Picture. Thank you very much for this wonderful moment at the SFSCon. So now there will be Lisa joining the stage for Luisa. Oh, sorry, Luisa. We are going to have a break. Okay, so unexpected break. We thought we have no breaks during SFSCon, but we have a break of 10 minutes, and afterwards we will have Sarah Gallian of the Eclipse Foundation talking about the software-defined vehicles. You remember my socks? So I'm looking forward to her presentation. Have a nice break of 10 minutes.
Okay. Hello, everybody. I'm very happy to be here. And so I will be the moderator for the rest of the morning in this room. I'm Luisa Marangon. I'm working for the Noi Tech Park. And I'm responsible for the customer management and the cooperation of Noi Tech Park. So if you want to know more about what you can do with the Noi Tech Park, I'm the person you should contact. So my role here is to introduce the speakers and to keep the times. And I will introduce now the next speaker, Sara Gallian. She has a background in aerospace and electrical engineer. She has a PhD on numerical modeling of complex systems in the field of electrical engineering and information technology. And she leads now the working group of software-defined vehicles for the CLIPS Foundation. She will tell us about the first year of the CLIPS software as a successful code-first approach. Welcome on stage, Sara.
Yeah, so I hope you all can hear me, because today I woke up absolutely with no voice whatsoever, so I'm gonna do my best. I might have to stop for water, but yeah. So first of all, thanks a lot for the introduction, as I said. And yeah, so I'm here today to talk to you about our wonderful working group that's hosted by the Eclipse Foundation, and it's called the Software Defined Vehicle Working Group. So, but before I start, since it was mentioned today in several instances, I kind of suppose you all know, but you know, it's always best to refresh. What is open source? So open source, it means it gives you the freedom to run the program for any purpose you might like. Even if you are an evil dictator, you can run the software. It doesn't matter what's your scope. Freedom to study it, so to go deep into the detail and to change it. And then you can redistribute the copies, and you can also redistribute the copies that are modified. So this is the basis on which the Eclipse Foundation is basically based on. So the Eclipse Foundation is a foundation that was funded in Canada a very long time ago, and it was funded around the Eclipse IDE. Some of you might have heard about it, some of you even might use it, but we have come a long way from there. And we recently moved to Europe, and we are now the biggest European foundation. So we are hosting 410 open source projects. We have 360 members and 1,900 committers, and we do hope to see you in the future if you're not already as part of our group. So why I would like to talk about open source and business friendly. So the two words don't usually come together. But in today's economy, I mean, of course, everything we do needs to be supported, because you would like to be hired by an organization that does pay for your bills, right? So companies are looking for developers, particularly in the automotive field. There is really hunger for good developers. And developers like open source because they like to work with their peers. They like to exchange ideas. They don't like to sign NDAs all the time. So they do like open source. But finally, companies need to have governance. And this is what the Eclipse Foundation is doing and is proposing, a governance. And we have some focus areas. We have cloud-native Java. This is where we are working on and where we are maybe the strongest, but we also have IoT and Edge and automotive, which is what I'm going to talk to you today. And we are very strong in the tools domain as well. So I mentioned, for us, open innovation at an industrial scale is essential, because organizations need to be working and adopting open source. So what we provide and what our contribution is, we do provide governance. And the governance is the foundation for anything that is open source, vendor-neutral environment. On top of it, then our organizations, our members, our committers, they do work together in a collaboration layer where everyone can contribute, and of course, following the policies of openness, transparency, and clearly vendor neutrality. And then above the value line, this is where the organizations can compete, because they do need to have a business case. And yeah, so for sure, they do have a business case over the value line, but they have a huge business case below it as well, because we are talking about 20 billion euros of investment up to date in open source software. So what about the software-defined vehicle? That was an introduction to what we do. So I just want to briefly give you a motivation. So of course, when you think about software in a vehicle, you think about ADAS, so you think about advanced driver assistance systems and in general self-driving cars, but there's of course more to it. But even if you only focus on that, we have seen, we have observed that although the number of accidents is more or less constant, we are experiencing a lot less fatalities. It means that ADAS really works. So we are moving towards Vision Zero. We are not there yet, but this is a great motivation. And what this brings, however, is a lot of complexity. You have mixed criticality systems running on your vehicle. The world is extremely complex there. So basically, yes, ADAS saves lives, but it increases complexity. And we can tackle complexity only if we come together and we work together on the non-differentiating layer. So this is why we put together the Eclipse Foundation Software-Defined Vehicle, which has the mission of devising open source software specification and open collaboration models as well to allow a scalable, modular, and extensible industry-ready open source vehicle of the future. So just a couple of history slides about our history. So in the beginning of time, all of the organizations were doing their own things. They were developing stuff 10,000 times again, and until in March of last year, the Software-Defined Vehicle Working Group was born. And we spent quite a lot of time onboarding projects. And we have, one of our funding principles is code first. And what it means is that we will onboard any project that is given to us. And what this means is that we do have a K-COP project, because they don't fit with one another, they don't solve a comprehensive use case, but they are open source projects. So we started by building a community, because this is the foundation of everything that we do. Because if we are not adopting our own projects, then we are definitely not giving the example. We also started to change the mentality of the senior managers, because the senior managers hold the key to the FTEs and to the time of their employees. And then we did start to work on integrating our projects toward creating blueprints. And yeah, just to sum up, our governance principles are code first, because in code we trust, and this is our added value. We foster active participation. We make sure we have an environment that is vendor neutral, transparent, and open. And these are our members to date. We have 41 members. They are spread across the whole industry, starting from technology providers like Microsoft, through tier 2, tier 1s like Bosch and Continental, all the way to OEMs such as Mercedes. So we are spanning the whole industry. But I said code first. So what is it that we do? So I mentioned that we, by design, did not start by designing an architecture, which of course has pros and cons. But what it means is that we really can feel where are the pain points of our members, because they do give us the software that they have developed. They are the experts. And what we have been doing is onboarding all of these projects and trying to put them on a functional map. So historically, we did start mostly at the middleware layer, where we had service fabric and communication. So we onboarded a lot of projects about middleware and frameworks in general, communication protocols. We even have an in-vehicle digital twin project. But lately, the trend has been to move towards a tooling domain, so a DevOps comprehensive tooling domain to allow a fast and efficient, and of course open, development of the application software that is above the business line. But that's not all. I mean, we also have a couple of projects on workload and container orchestration. We do have a very interesting project that is a distribution, so it allows you to devise and to write together recipes for Yocto Linux with pre-integrated projects, so that even someone that is not very familiar with other projects can start developing. I talked quickly about integrating projects and improving collaboration because, I guess most of you do not really know, okay, so what is your working group doing? So what do I do with all of these different projects? They have weird names, I don't know what they do. And yes, that's a very fair point. So this is why we have been focusing, since we do have a critical mass of projects, we have been focusing now on interfacing them with one another. And what this means is we are creating blueprints. You can think about blueprints as our working group business card. So what use case can you solve if you combine our projects? And here are a couple of examples, and I can go a bit more into detail. But for instance, with our open source projects, not only the one within the SDB working group, but also others, and what you see here in the architecture on the right, and this is an architecture because it does solve a problem, is based only on open source. So you can implement a fleet management system that helps you to abstract from different kind of hardwares on different kind of vehicles on different kind of database platforms, just and only using open source projects. And I think that's extremely powerful and a very concrete use case. Another one about orchestration. So think about you want to go on a travel and you want to attach a trailer to your car and change the way that your car drives. So changing basically the body functions of your car. You can do it with entirely open source software and open source projects. So the system detects a smart trailer, a signal is raised to the orchestrator, and here it's to showcase our orchestrator projects, for instance, and then the body functions and powertrain are adjusted accordingly. So there is a part that runs in the vehicle, there is a part that runs in the cloud, and also the way the car drives is changed. So some of you might think, okay, that's all nice and good, but what about safety and security? So maybe you're not familiar with the automotive world, but who is extremely opposed to open source software because of the safety relevant applications. And I mentioned ADAS, but also body function control is another example. So the world today is organized based on a number of ISO norms. There is the Automotive SPICE standard that basically is a collection of best practices that tells you the process to develop high quality and compliant code. There is the Automotive Functional Safety Standard, that's the infamous ISO 262, and basically it asks of you a number of artifacts to have safety relevant software. And then finally, there is, of course, the cybersecurity standard. And if you think about open source, so open source is very impacted by cybersecurity, because by cyber attacks, because your code is out there. So anyone can find a weakness to it. So what about open source? Where does it stand there? So there is a lot of discussion going around it. And what we want to make sure as Eclipse Foundation is we want to make sure that the maturity of our project is transparent and that we do enhance our existing project protocol and handbook by adding some ingredients that allow us to be more easily integratable. So not only do we want to cover a broad spectrum of projects that allow you to really write applications, but we want to make sure that whenever you use our project, you know what is their maturity, what is their capability, and whether they can be considered safe. Of course, we are not going to certify them anytime soon, but you can find what artifacts are available. So I hope you are interested in knowing more about the working group. How do you participate? I mean, everything we do is public. We have a bunch of mailing lists. We have Slack channels. We have a bunch of activities that are open to everyone who wants to participate. We have technical alignment calls where we do invite experts. Even if you're a student and just want to know more about it, you can come to our technical alignment calls. You will have a dedicated presentation by one of the experts on a certain topic. And then, of course, we do organize Community Day and, most importantly, hackathons. In fact, we are starting our very first full 2 days hackathon in a couple of weeks in Munich. Yeah, I'd like to invite you to join and to check out our projects directly. All of our project leads will be there. They will explain to you what their project does and how can you interface one with the other, and just try it out yourself. And with that, I'd like to thank you for your attention.
Thank you very much, Sarah. So if there are any questions in the room, I will be happy to hand over the microphone to you. Otherwise, we will wait just a couple of minutes in order to then start the next speaker, the next speech. And so we will need to keep those time like parallel for each room. And so that's why we need to wait a couple of minutes. So in the meantime, thank you very much, Sarah, again. I will slowly go back on stage. The reason why is that I have to introduce now two speakers. And so since I don't want to steal them time, I introduced you a little before. So our first speaker is, one of the speakers, it's Emily Byrne. She's a high-performance computing application expert, and she's working for the PFL, where she works on fusion plasma simulations. That also was a focus on her PhD at the French Alternative Energies and Atomic Energy Commission. She has degrees on physics, computational science and engineering, and a doctorate in applied mathematics. The second speaker, just one speaker, so just Emily. So Emily, she will tell us about Pixel. Yeah, so welcome on stage.
Yeah, hopefully you can hear me. Okay, I don't know if anybody heard the introduction over the music, so I'm going to be talking about Pixel, which is a piece of open source software which helps you write Python code but get Fortran speed. So I know a lot of people like Python, probably also in the open source community. It's really great because it's very beginner friendly. It's easy to write, fast to use. There's loads and loads of often open source libraries that you can use to make things go fast. It's portable, it runs everywhere, and there's a large community. And so if you're looking for people to work on something, if you're writing it in Python, it's easier to find people because a lot of people already know Python. But it does have some major drawbacks. It's known for being quite slow and quite memory intensive. And for certain problems, for example, a recursive problem, it can be a little bit limiting. So here, for example, we have an example. The Ackermann function is a known recursive problem. If you try and run this in Python with arguments that are too big, it just fails as a recursion error. You can fix it, but it's not ideal if you have a big recursive problem. So what's Pixel? Why is this going to help? Pixel was written at a university originally. And in the university, a lot of the time, we write code in Python to test it out because it goes a lot faster. But then we can't run it in Python because it just takes too long. So we write it in Fortran, and you have to translate it. And it takes a long time. And so Pixel originally was a transpiler. So it translates from Python to either Fortran or to C. But then from that, we've added an API, a wrapper level with the CPython API, which means that the translated code can be called directly from Python, and you can interface with it in the same way that you would with your original Python code. So here is an example. On the left, you can see a linear convection equation, which solves the linear convection equation using finite differences. So you can see this uses the NumPy library. It has loops in it because there are dependencies on the previous iteration. And so you can write this without the loops, but it doesn't look as nice. And loops in Python are just really, really, really slow. And so if you run this with Python, for example, here it takes 1.5 seconds if you have a big problem. But if we use Pixel to translate it and wrap it, then we can call it in exactly the same way, but it only takes 1 millisecond. So here we have a speed up of 1,000 times. And in this case, we have a program that's running, and so we can translate the whole thing. There's nothing in there that's particularly complicated, so the whole thing can be translated by Python. And then we can run it as an executable, and it takes a lot less memory. So when we run it with Python, it uses 6.4 megabytes to handle all the different things that Python does in the background. But when we run it directly, it's only 60 kilobytes, so 105 times faster. And so this is the code that it generates. I think I've just included the Fortran code, but there is a similar C code. And so you can see here it's still quite recognizable. We have the same loops that appear that you can recognize. This code looks very, very similar to the code that we had on the previous slide. And that means it's readable. So a lot of things that accelerate the code, you can't go and check if what it's doing is what you think. But in this case, it's completely readable. And so if you need to... Okay, sorry. So if you need to use the code for something else, you don't have to rely on Python. You can take the translated code and use it directly. So if this sounds useful, then how do we go about that? the first thing you need to do is to install it. Pixel is available on PyPy. If you're using Linux, then you usually have the dependencies installed already. If you're on Mac, maybe. If you're on Windows, it's a little bit more complicated, but it is definitely possible. You just need compilers, basically, for Fortran or for C. And then once you have that, you can call Pixel and your file, and it will generate all the different files that are necessary. So probably I should mention, the one thing that you do need to do for that to work, though, is to add the type annotations. So you can see here that we've said that nx is going to be an integer, dt is a float, and nt is an integer. And where possible, we do try to support annotations that work for MyPy too. So if anybody uses Python a lot, you know that MyPy is there to statically check your code to make sure you're using the right types. And so it should work with it. The only thing you can't do with that, though, is NumPy types. There is no neat way of doing that in MyPy at the moment. So instead, we use string annotations that, yeah, and you can find the documentation for that on the GitHub page. So obviously, Pixel isn't the only tool that does this. So one thing that we can think about is why Pixel? Why not anything else? So some of the different tools you can use, a lot of people might have heard of Cython. There's also PyPy, which is another way of running Python code. So usually when you run Python code, you use CPython, but you can also use PyPy as a different interpreter. And then you have Number and Pythran, which work similarly to Pixel. So we don't like Cython very much. It's a good tool, it works well, but you have to add lots and lots of type annotations. And by the time you've finished, your code doesn't run in Python. And why not just write it in C if you're going to get something that looks like C and doesn't work in Python? But all the other tools, you can work in Python, and then when it works well, you run it in the right language, and you have access to both versions. Another thing to think about, I tend to use these tools on big machines where I don't necessarily have sudo privileges. I found it quite hard to install PyPy and Number on some of those systems. Almost all of the tools need type annotations. PyPy doesn't because it's just a Python interpreter, but all of the rest of them do. And they don't all translate everything in Python. PyPy is an interpreter, so it manages everything. But for the others, you do have to find the bits that are slow and then just translate those. And then there's a few other advantages, whether they can handle multiple folders, how well they interface with pure Python code, how well they can interface with any code that you might have pre-written in C or in Fortran that you just want to use directly. And then there's different speedups. So in the next couple of slides, I'm going to show you some benchmarks. So I'm not going to include Cython because it's too much work to translate the code. And I'm not going to include PyPy because it's just an interpreter, and so the gain that you can get from it is generally not as large. So here we can see the speed up that you can get, and in this case, all the codes that we used for the benchmarks were written with NumPy where you could write NumPy. So you can see that you can have a massive speed up, but obviously it depends quite a lot on the problem. So for example, the finite difference linear convection is the one that I showed on the slide earlier. You get a huge speed up because it needs to be written with loops. So even if you're using NumPy, you're not benefiting from NumPy fully. But then some things like the Laplace finite differences relies heavily on the NumPy tools, and they work well. And so then you get quite a small speed up because NumPy does it well anyway. So that's something that you need to think about when you have your code. Look for the bottlenecks and see if there's any point in translating things. If you have lots of loops, then probably it's worth it. Another thing to think about is how long it takes. So if I run my Pixel and then my file command, how long until I have something that I can use from C? And so you can see Pixel is the last 4, it's generally not particularly slow. But Pythran, which is another tool, which you can see on this slide is often really competitive with Pixel, it takes quite a long time, especially if you have a large file. So that's one drawback. And I should probably mention Number and Pythran. you can't see the generated code. Python, you can get hold of it, but it's very, very heavily templated C++ code, and it's very hard to read. You won't recognize your code when you get it back. Okay, so then, yeah, the conclusions are that with Python combined with Pixel, you can get really speedy development where you write everything fast, and then you can run the code very fast. The interface is quite simple. It just uses the type annotations. The code that is generated is human readable, and it's either Fortran or C. We also have support available for OpenMP, and some support for CuPy that's currently in a fork. So if that's interesting, then we can give you the information about that. We're open to open source contributors, and we have quite well-maintained docs, so we regularly have new contributors, so people that are working in their masters and don't have much experience with code. So we try and make sure that we have well-maintained docs so that they can start working on things without having to ask hundreds and hundreds of questions. We have a Discord server if you have any questions, and Pixel is already used by some other open source projects. So I could mention Strufi, which is a code for plasma physics PDEs, and PsyDAC, which there's a presentation at 12:40 about this, which is a Python IGA library for large-scale simulations. So I think I'll stop there and see if anybody has any questions. Got about 5 minutes left.
In the performance slide that you show us, I saw that consistently the translation to Fortran is better than the translation to C. Is correct? And what is the meaning, the reason for this?
So Fortran has arrays in the language, so it's usually well written. In C, we rely on our own implementation for arrays, and it seems to be suboptimal. So we need to go back into that and have a look at that. At the moment, we're adding support for lists and sets and dictionaries, and we're going to rely on another open source library to help us with that. And they have support for arrays. So I think while we're doing that, we're going to test if their array support is better than ours. Probably it will be. And then hopefully we can make up some of that difference.
Can I ask you a question now? Thank you very much for the great talk. I was curious to understand what kind of libraries can be implemented inside PyCell. Namely, all the Fortran, I saw like a list of Fortran codes that you translated into Python. I was curious, is it limited to mathematical equation solving, or can be applied to a general framework? Like, I don't know, kind of machine learning, or applying to large data sets to analyze data sets, or so on?
So the applications that we usually target are mathematical, but it's just a translation. So you can translate whatever you have as long as it's written in something that's compatible with Pixel. So the library support that we have is mostly NumPy. Yeah, so we support CMath and Math and NumPy, but not really any other libraries at the moment. But if somebody wants that, then they should put a message on the GitHub, and we would work on that. Yeah, so it works well with NumPy, which means it's good for mathematical things, but...
Okay, perfect. Yeah. Thank you very much.
Okay.
Okay, so if there are any other questions, I thank you very much for your contribution. And so a big applause for our speaker. Thank you. Good, so now we wait a couple of minutes. Thank you. Okay, so we are back for the next speaker. So our next speaker, Yuri Solovyov. It's ISTQB certified software quality engineer with 4-year experience at Red Hat. So he previously worked as a front-end developer. He's originally from Estonia, but he's now located in Brno in Czechia. And he will explain us how to deal with flaky text, because apparently this is a very issue. So welcome on stage, Yuri. The floor is yours.
Hello, everyone, and my name is Yuri, and today I'm going to talk about flaky tests and how to deal with them. And before we start, let me introduce myself a bit. So, as I said, my name is Yuri Solovyov. I'm a software quality engineer working at Red Hat and based in Czech Republic, and working on such projects at Haute, Camel Spring Boot, Camel K, Camel Quarkus, and also side projects. I work on Red Hat Summer Camp Brno, it's AT camp for high school students, and also time to time leading a seminar on test and practice at Masaryk University in Brno. So, and today we will discuss what are flaky tests, give them definition, then we will check the origins of flaky tests, and I will share with you some good practices we apply in our team. Then we will have time for Q&A. And first is the question, what are flaky tests? And the flaky tests are defined as tests that actually return both passes and failures, despite no changes to the code or the test itself. And here I want to share you one of my favorite examples. It was originally given by one of the main developers of Selenium test framework. But yeah, I want to show you. If you're not familiar with Java or Selenium, don't worry. It's quite a simple test scenario, which actually navigate to Google page, then you find a search bar, send keys like SFSCon, then you find a button with submit type, click on it, then you assert the results. And the questions are, what can go wrong? Or even which line of the code may break your test? And the answer is anything at any time and any line. So I will briefly explain why and what. So the first line can break because of slow or no internet connection. Your Docker image is shut down, like anything. The second line, just simply your desired HTML element is not drawn in time, and rendering speed was really low. And the most interesting is the third line of the code. Let's have a look at this in details. And as you can see on the first image, there are two such buttons with submit type. And if you open DevTools of the Google Chrome, you will find out there are actually two more, which are hidden. And the test will try to find the first found button and click on it. So it may pass, but at the same time, it may fail. And the possible fix can be modify the code just to find the button by its name. In our case, it's BTNK. And what will happen next? The flakiness is still there, because once you start typing in a search bar, the first button is hidden. Then drop-down list shows up and show you another button. And if you look at the DevTools again, you will find two buttons. And it may pass, it may fail again. What can fix it? One of the solutions is to use a framework with smart built-in timeouts and retries. In our case, it's Selenit, which is fully free and open source tool, and it helps us as it waits until your desired element is fully drawn, visible, clickable, accessible, and it tries several times to perform the action. And the code could look like this, using Java and Selenit. Okay, let's talk about the origins of flaky tests, why they show up. And there are many reasons. It can be related to your test environment, like lack of memory and space, caching issues, can be Docker or Jenkins issues. It can be a related connection, like request and responses, speed and their order. Can be test frameworks, as I mentioned already, like version mismatch, drop support, and new bugs. Okay, let's check the test frameworks based on our examples from our daily work. Here, there is one of the examples. Our tests were passing, but sometimes they starting failing with really unclear error message that underscore.filter is not a function. And the issue was that web application was completely stuck, like nothing was clickable at all. And it got unstuck only after page refresh, and the test continued. And when we tried to find out what happened manually, it worked fine. And it turned out that the root cause was updating to Selenium version 4.12.0, which caused that Selenium was overriding underscore sign. And what we learned from it? It's not always a good idea to blindly update all your versions or use dependent bot on your GitHub project. So you can hit a new bug, or you can get lost support, as we did within our library. So they just dropped Java 8 support, which is still in our test matrix. Also, it can be version mismatch of your framework, some capability. They may bring new changes, deprecated methods, and everything else. Okay, so let's check test environments, how they can introduce flakiness to your tests. Here, there is a screenshot of one of our Jenkins job, and the test scenarios were passing, but at some point, randomly, they started failing. And the error message might seem quite straightforward, like some HTML element is not found. However, when we rebuilt the job, it helped to get it passed. But still, it was failing and passing in a really random order. And what could go wrong? Again, anything. Lost internet connection when pulling images, hit pulling key limits, lost connection to testing machine, or lack of memory and space. And what actually happened? We have application deployed on OpenShift, and it becomes unstable after a while. it was continuously stopping and restarting with the error message, liveness probe failed. And it didn't provide any detailed message what actually happened, what was inside. And after our investigation, we found out that it was caused by AppSpot exceeding its memory allocation on OpenShift. Moreover, the resources weren't defined by default at all. And what helped us to fix it is to define explicitly and increase memory allocation. And there are a few key points which helps us to keep low level of flakiness in our test environment. First of all, for sure, clean up your clusters, terminate unnecessary machines, remove namespaces, projects. Also keep track of internal repositories, like get rid of unused or outdated artifacts, which take space. And of course, don't create large machines for really low cost work. Another thing is, if you have pipelines in parallel using the same resources, sharing the same cluster, avoid deadlocks. So add checks, add conditions, timeouts. For instance, we had one issue when one job didn't start because of lack of resources. The second job was dependent on the first one, and it created a really huge queue of the jobs. So, and it was a really big pain to get rid of this and fix it. So don't repeat the mistake. Another key is infrastructure. So make sure the connection is stable, it's accessible, VPN is up, nothing is overloading your network, no leaks, and there are no outages are happening. Again, we hit one issue when we started our pipelines, but our responsible people didn't know that there is planning outage of our infra for maintenance. So we just wasted 2 days of our work, unfortunately. And yes, application under test can cause flakiness as well. It can be performance of your application can be too heavy, too slow to be handled. Also can be bugs introduced by developers. Also it can be related to runtimes where you run your application. So, and I will give you 2 examples. One example is our older version of our application was written on AngularJS, quite old technology. And the thing is that loading order of modules wasn't explicitly defined. And sometimes rendering of the page was faster than modules get loaded. And it caused a missing logout button. As you can see, it should be there, but it's not there. Yes, it sounds like a bug, true, but the tests sometimes were passing, sometimes failing. So the behavior was quite flaky, even though it was a bug. But luckily it got fixed quite easy. The second issue was with broken layout for drop-down menu. Yes, again, it's a bug, but it was pure flaky for us as the tests were mostly passing, as they were able to find the option. And the tricky thing was that all the tests are running in the background with no UI at all. So it required to us to do manual job to deploy it, to check it, and find it. For us, it was easy to get it fixed, luckily. Okay, and now I want to show you some good practices we applied in our team. As I mentioned before, consider test frameworks with built-in timeouts and smart retries. Do not use common locators, but unique ones like names or even IDs. And if they're missing, so collaborate with developers to learn from each other and deliver the product with higher quality. And also beware of version updates. Yes, keep an eye on infrastructure, space, memory, hanging jobs, machines, and it's always good to know your application under test and be familiar with the application infrastructure to develop tests effectively with low cost and decrease number of potential flaky tests and easily debug it. And as a conclusion, I want to say that flakiness consumes resources and time from the product team. And it costs money, imaging. Instead of focusing on new tests or new feature development, you're focusing on the existing continuously failing tests. So it postpones releases, the company loses its profits, it loses customers' trust and company's reputation. So everything costs a lot. And yeah, that's it. Now time for questions, if someone has. Thank you.
From the public? No, not really. So you were well explained. So thank you very much.
Okay, thank you so much.
Yeah. So we wait for a couple of minutes for the next speaker. So thank you again, Yuri. Okay, some of you came back from the break, small break we had. So I will start now to introduce our next speaker, Yaman Güçlü, and he works for the Max Planck Institute for Plasma Physics as a staff scientist. He holds a PhD in aerospace and engineering from Padova, and he was also a visiting research scholar at the Michigan State University, and also he has a postdoc at the Max Planck Institute for Plasma Physics. So he's researching this sweet spot between applied mathematics, numerical analysis, computational plasma physics, and high-performance computing. And he will tell us about PSYDAC, the Python EGA library for large-scale simulation. So welcome on stage. The floor is yours.
Hi, so thanks a lot for being here. So this is maybe a bit of a technical talk. It's the first time I actually present this to public that is not really into the topic. But for me, this provides a blueprint of what you can do with certain practices. So, and I hope then this can be applied to similar software. And okay, this is very sensitive. Yes. So the whole point is that you can actually write quickly software in Python, and you can run high-performance computing level simulations with Python. Okay, and we have a recipe for this, and this should, in our opinion, is a way to solve the problem in scientific computing. Okay. Perfect. Okay, so first, obviously, we would like to have, in scientific computing, often you have stuff that is written by students. There is a lot of software, a lot of good algorithms written by students often. And some of this, just a small percentage, becomes eventually software can be used to do something useful. Because, in our opinion, there is a bottleneck to be solved there. So a prototyping environment has to be user-friendly, interactive. You want to be able to have many numerical libraries, access to visualization tools, data analysis. But on the other hand, on the other end of the spectrum, you have high-performance computing requiring single-core optimization, shared memory, MPI parallelization. You want to use heterogeneous computing systems and apply strict quality control. And now we have a huge gap in between. So this is why many projects die, because you don't have the resources to move from prototype to production. So our strategy here is to write the code in Python for many reasons, that were highlighted before in Emily's talk. And then actually, if needed, we also generate some parts of this automatically to have more flexibility. And then MPI parallelization can be done, and based on the MPI for Pi library, that is an excellent library, it has very little overhead, and you can translate bottlenecks to Fortran OC using, for example, the Pixel transpiler. And then if you really need more performance, you can still give the Fortran or C code that you generate to an HPC specialist to further optimize the code. Okay. So here I'm talking about PSYDAC. This was created at my institute, IPP, Institute for Plasma Physics, and it's for spline finite elements, which were used in many other codes. So it was natural to just try to build one library that could support the needs of the institute. There are many reasons. One is that they can represent complex geometries. Many CAD tools use splines, and so it's nice to actually use the same splines for doing analysis. They provide smooth solutions, high order of accuracy. You can do more sophisticated stuff. And so in 2018, we created PSYDAC. So the idea was to have a fast prototyping environment for with high model flexibility, being able to experiment with new distributed data structures, and then we wanted to be able to achieve high performance with code generation. We all obviously thought, could we actually use another open source library, or could we extend it? We had certain requirements, and in the end, we decided we needed to write something new because there was just too much to be changed. Okay. So the PSYDAC project has three main components. One is PSIDAC, which relies heavily on Pixel and SymPD. So Pixel was a talk before, and SymPD I will briefly mention. So the simulation workflow is pretty typical. You have a geometry file, you have your main script, which uses PSIDAC, and probably you have a post-processing script to analyze the data afterwards. And then you have two phases. PSIDAC can be the online phase, where you actually do some physical simulation, which generates an output file, then an offline phase, where you post-process the output file to generate a VTK file, and then you can visualize this with ParaView and do 3D visualization. And here, two things is important to say is that actually the online phase, the offline phase, and even ParaView, they can all run in parallel with MPI. Second thing is that here, what I write as a mains and the post-processing script could be actually another library that uses PSIDAC. So you could have an application library specific for maybe one model only, and that will use PSIDAC internally. So the library itself has many ingredients. So there is a lower level layer where there is linear algebra. So you have distributed vectors and matrices, linear operators, iterative linear solvers. Then the part that has to do with splines per se. So we evaluate B-splines or non-uniform rational B-splines called NURBS, evaluate derivatives, whatever is needed, being able to insert knots and change the degree. This is typical to CAD. Then we have a geometry layer that has to do with how the geometry of our domain is built. We have multiple patches connected with, and each of them could be mapped in a certain way. Then the middle layer has to do with finite elements, and this is very typical. Here we focus on spaces that are tensor product, and then we have vector spaces and so forth. So the finite element space is on top of what's below. Then we have an high-level API where we have the typical objects of a finite element method, like bilinear form, linear form, functionals, and so forth. Or maybe something more specific for what we do, which we call finite element zero calculus, where you can access gradient operators, curl operators, divergence operators, projection operators, and so forth. We have an output manager, as I mentioned before, and then we have a layer where we do code generation. Okay, so parallelize the code is very typical. We decompose the domain, then we parallelize everything that is on the linear algebra layer, so vectors, matrices, and the important thing is that because of how linear operators work, they need a bit of information from nearby entries of an array. So in practice, you need ghost regions that you have to update. And so this is where MPI communication comes in. Okay, so another important part is that the computational kernels are where there is most of the calculations in the library. We actually translate automatically to Fortran or C using Pixel. So this is for evaluation of our splines, for a matrix vector product, for calculating the inner product between vectors, transposing matrices, converting to other formats which you might want to use, and assembling matrices, vectors, and scalar functionals that come out of a finite element method. Also, you can actually add OpenMP pragmas in your code, which you couldn't with just Python. So Pixel supports that, and then it will actually print the corresponding OpenMP pragmas into your Fortran code. And this way you can bypass the global interpreter lock of Python, and you can achieve parallel multi-threading of a code that earlier was just running with a single thread. So in practice, how the automatic code generation part works is that you have a language that you use to describe your problem. You model equation, and this is provided by the SymPD library. And then the user also selects the geometry. PSIDAC creates the spaces, decomposes them using MPI, and generates the computational kernel specific to the model you described. Okay, and then these are generated in Python. Then Python is translated to Fortran. And if you want, you can also directly solve the linear system with one of our solvers. So here I have an example just to show you how it looks like. So this is just using SymPD. So you really have a match between, so what is a continuum model in weak form, if you've ever seen any. This is typical finite element methods. So it's a variational form. So you say, okay, given some right-hand side, find a certain function u, such that this expression, which is an integral expression over the whole domain, holds for every test function in a certain space. So all finite element methods look like this, or worse, more complicated than that. Okay, so, and this is exactly what you write in using the language provided as in PDE, you see. And you can add essential boundary conditions, for example, and eventually write really an equation. Okay, so SimPD, I said a few things about it already. So it extends the Python library SymPy. So it's a symbolic algebra system. It is a domain-specific language, and it also gives you the tools for processing the expressions into another library, like PsyDoc. And it provides, as I said before, some partial differential operators, can also satisfy operator identities, like the divergence of a curl of a function has to be 0 automatically, gives you the integrals and so forth, and can also check that what you write makes sense. So if you say that something is linear, it actually checks if it's really linear. Okay. And if you want, you can inspect the expression tree, because this is a SymPy expression tree, so you can visualize it with the SymPy tools. Now, here comes PsyDoc. So you actually have a single entry point. Okay, this was a design choice we did a while, which is this discretized call. And PsyDoc takes what you defined using SimPD. You provide additional information about how you want your space to be once you discretize it. So here, how many cells you use in your domain, what's the spline degree, so the polynomial degree, and then you really go through the discretization, and here also you have a communicator. Okay, so and then it means it also decomposes the domain using the MPI processes that are available. Okay, so this is the example that you get by running the code. So this is just to check that I can distort the mesh and still get the exact solution that I built with a manufactured solution. And also I can actually compute the error with respect to the exact solution in this case. So I can assemble it and I get an error. Okay, so in terms of performance, we compared to a C library that is well known called Petiga. And not immediately, but after a while of some work, we actually managed to get this considerable speed up. And this is as speed up as I increase the number of cells compared to Petiga, and change the degree of the polynomials that I use, and how many processes I use to distribute the work. So, so the first is for the assembly of the stiffness matrix. The second is the matrix vector product, which is fundamental if you use an iterative method. All right, so to conclude, here we showed an example where we can bridge the gap from prototype to production in scientific computing, where usually you don't have access to lots of human resources. And you can use Python to experiment low-level algorithms and the high-level library design as well. And you can achieve flexibility if needed through the domain-specific language, semantic parser, and code generation. You can use a Python accelerator like Pixel to get single process performance as you statically compile the most computationally intensive functions. And you can achieve parallel multi-threading with OpenMP. And here we also have a fork where we experiment with GPU offloading. So hopefully that will be functional as well pretty soon. And you can use MPI parallelization through the MPI4Py library that we observed works very well with pretty close to no overhead compared to Fortran interface or C. And with this, I conclude. Thank you for your attention.
Thank you very much, Eman. Are there any questions? No? It was very interesting and very complex, but still, yeah. So thank you very much for your contribution. Thank you. will slowly start again, and I'm very proud of you because I'm hungry, and I suppose all you already eaten or you're hungry too. So I will introduce now this next speaker. Matteo Valentini, he's a developer at NetAsys and open source contributor of the NetServer Linux Foundation. So his interest split between backend development, infrastructure development, and automation of all the things. That's very interesting for our next speech because he will explain us the hidden cost of automation and when automation backfires. So welcome on stage, Matteo, the floor is yours.
Okay. Hi, everybody. In this talk, we are going to see some drawbacks of the automation. The automation is often presented as a solution. If you have something complicated, you can always automate and call the day. But there is also some dark spot of automation that you have to be aware before starting. Before start, let me take a little introduction of automation and the automation concept and benefit. We can define the automation of like the use of machine or computer instead of people to do a job, especially in factory or office. Right now, we can see some key advantage, that is the removal of the human and the use of a machine or computer for do the job instead of human. With this, we can reach some benefit. There are the speed, because a machine is more faster than a human to do a specific job. Okay, specific job. And then because we remove the human factor, we remove also the human error, because a person is not so good to do a repetitive test. We also have as benefit the scalability, because if you want to add more throughput to our process, we can simply execute an automation in parallel. And we have also the repeatability, because if you want to redo something, we can execute the automation. If you want to do something that we have done in the past, we can re-execute the automation with the same parameter and obtain likely the same result, or if we want to do in the future. Also, because we don't involve the human and we do the thing more faster, we have also a cost reduction. A good example of automation is all the CI/CD principle pipeline, where we can automate the execution of the testing on every improvement of our product or a service. We can automate the release of our software, deploy, likely also the operation, monitoring, and the build of the code. So now maybe you are asking, where is the problem? Or where is, in reality, most of our automation can end up like something like that. This one is a Rube Goldenberg machine. If you don't know, it's a machine that was invented by a cartoonist, Rube Goldenberg, and is a chain reaction type of machine that is designed for do a simple task, but in a very complicated and indirect way. Personally, I think that sometimes we end up in something like that because we, as engineering developer, like to do the complicated things. We like this type of thing, but we have to be sure about what we are doing. And in my experience, I think that I've identified four main problems that I call four main anti-patterns that I call the fortnight of apocalypse. That are the technical debt multiplier, the golden hammer, the silver bullet, and fragile software. Let's start with the technical debt multiplier. A technical debt multiplier is an anti-pattern that we have when we try to solve complexity with complexity. If you have a complexity problem, we tend to put on top of this problem an automation that adds more complexity, and is well represented, in my opinion, with the Adler law that states that improvement means deterioration. So every time we're going to do something to our system, our software, our automation, we are going to add more deterioration or hide deterioration for the future. An example can be that if we want to create, we create a new product that is based only the mere automation and legacy product. Right now, we will end up with the technical debt that we already have, that is a multiplier with the automation process. Or when, for example, we execute all our tests on every Git commit to Git push, but we are going to do that because the process is too slow and the setup of the environment of the test are too complicated, and our developers don't want to use it. Technical debt multiplier is well represented when we are going to use the automation as a mere glue of our technical debt. The other anti-pattern is the golden hammer. The golden hammer is manifest when we are going to use automation for everything. We are going to automate that. Is well represented, in my opinion, with the law of instrument that stated if you give a small boy a hammer, and she will think that everything that occurs needs to be punting. Or if all we have is a hammer, everything looks like a nail. An example of this anti-pattern is the use of too many specific features of an automation platform. So when we're going or we need to migrate to another platform, this will be very difficult. Or maybe we are going to build a procedure we are going to automate a build procedure that can be executed only on the automation platform because it's too complicated and They take many parameters, many secrets. For manage that, we are going to put everything on the automation platform and execute from here. Or when, this is one of my faults, use a GitHub action like a cron job platform. Yes, you can do it, but it's not so useful. And this anti-pattern can be represented with the use of automation in the automation platform, even when it's not necessary or needed. The silver bullet anti-partners is well represented when we are going to build an automation with the intention to build one time and never touch it. An example of this automation is when we are going to write an automation that is too tailored for the current problem, because we think that this is the only problem that we are going to automate to solve with automation. Or when, for example, we write an automation but is take too generic and many unnecessary parameters because we want to solve the current problem and maybe the problem that we are going to encounter in the future. This type of anti-pattern is well represented with when we want to solve with automation the problem that we encountered in the past, that we have in the present, and that we will encounter in the future. The last anti-pattern that I identify is like there is composed of the past anti-pattern, that is the fragile software. A fragile software is a software that is so complicated that you don't want to touch. You are afraid that every time you are going to touch this software, in this case, or this automation, we are going to break it. Because if you do, for example, with the silver bullet software that is too complex, nobody wants to touch it, to modify it, so because you are fear to break it. And the lack of documentation, this means that nobody knows how to touch it, and because you are afraid to break it. Also, if fragile software is a software that is too dependent on the platform, so too much more work to move it, and nobody wants to do that, and only work on the platform. This will end with an automation software that is too slow to improve or edit, and at the end, nobody wants to use it. So, what can be a solution of this problem? In my opinion, one solution are the good patterns that we can apply when we are going to approach an automation, that is Start simple, then evolve your automation. You don't have to solve everything right now, but you can improve in the future. This means that write a maintainable code because you will need to edit in the future. Another thing that is be sure that you can execute your automated code also outside the automation platform. This can help with the use or a Makefile or a shell script instead to embed all your code or your business into the YAML file of the automation platform. Also enable local dev environment so your developer can re-execute in their laptop the automation. And write also documentation for your automation process. The automation process is not something special. It's not something that is auto-explicative. It's not something that nobody will have to edit or to touch. So write code also for documentation. What conclusion we can take from these good partners is that the automation is also software, so we can apply the good principle of good software. Another thing that is another mistake, in my opinion, that we do something is to use the automation as a tool for fix our technical debt. If we try to do something like that, we will encounter in the future some problem because we are not solving the technical debt, but we are going to multiply or add more technical debt. So before you use automation, solve your technical debt, then automate it. That's all. Thank you for listening. I'm Matteo Valentini, developer at Netelis. If there is any question, I'm happy to answer it.
Thank you very much, Matteo. Are there any questions from the public? I heard some chit-chatting in between. No? So sometimes it's easy, it's automation, it's not everything. So sometimes easier, it's the best option.
Yes.
So thank you so much for your contribution to SFS.
Thank you. Thank you.
the next speaker is already ready on stage. I think he's keen on heavy lunch, actually. So we'll be very brief to present him. So he's Gabriele Santomaggio, and he's a senior member of technical staff at VMware. And he's a lover of distributed system and open source addicted. And he will show us the experience with writing clients for RabbitMQ for stream queues. And we will see how to reduce the latencies and many other things. So welcome on stage. The floor is yours.
Let's wait 5 seconds. 3, 2. Thank you. Okay, so speak at 1 p.m. is some unfair, you know. At this time, usually people eat or sleep. So if you want to sleep, feel free. Just because I can't, you can. Okay, so let me introduce myself. My name is Gabriele. I work for the RabbitMQ team in VMware. Do you know RabbitMQ? Raise your hand. A lot of people. Do you use it in production? Well, so. Okay, so starting from the version 3.9, we introduced a new kind of the queue called the stream queue. I don't know if you are aware about that. It's a totally new kind of the queues that is different from the classic queue or quorum queue. The aim for the streaming queue is to handle traffic, throughput, to handle a lot of throughput, and to handle large fan-out, so a lot of consumers. And another aim is to replay the messages one time. And each single message has its own offset, so the consumer is just a pointer to the stream. So just to give you an introduction. And speaking about performance, we are speaking about millions of the messages per second, which is a lot. In our internal test, we reach more than 30 million messages per second for dedicated tests, of course. In your local machine, you can reach 1 or 2 million of messages per second. So, and did you know about the stream part of RabbitMQ? No one. So it's cool. You learned some things today. In this talk, I'd like to share our experience to write the drivers for the new part of the RabbitMQ, because the server can handle this kind of the numbers, but the client must be able to reach this kind of the numbers, which is not so easy. And the topic itself is complex and maybe boring, so I decided to tell you 2 stories about 2 different clients, .NET and Go, and 2 issues, actually. And just to let you know, we are writing different drivers in Java, Python, Rust, Node.js, or wherever. So if you use one of these languages and you want to contribute in our repository, you are more than welcome, because we need contributors. Do you know .NET? Do you use .NET? Someone? Yeah, raise your hand. Okay. Golang? Yeah, more Golang. All right. Rust? Okay, we have more or less everything. So the first one is .NET. The first problem, oops, too much. The first problem was about performance problem. A user reported an issue, and he says some things. I have a performance problem. In order to download 88 million of the messages, it takes 35 seconds, which is too much. And I don't know why 88 million of the messages, but this is the number that we have as, reference. And so the problem was client side, because using another driver, the performance was better. So the solution for this kind of the problem, after debugging, profiling, analyzing, blah, 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 was this one. So basically cut the code. We had to remove the code in our driver, because the code was
well written, so different layers, documented, different classes, blah, blah, blah. But the problem is that we had too many layers between the socket and the user callback. So one of the first optimization was to cut all this layer, reduce the layer between the socket and the callback. This because we had a lot of the memory allocation. Allocation is not free, especially when you have millions and millions of the allocation for second, and the allocation is not absolutely free. And another optimization was to replace the slice. So when you have a byte array and you want to parse the byte array, if you use like copy or slice or stuff like that, is a new copy of the array and new and copy, which is slow. Normally you don't care, but speaking about this number, it matters. And using this sequence reader is just one allocation, just one time, and use this allocation for all the steps. Another optimization was to make the parse asynchronous respect to the main thread. So it means that meanwhile the driver is parsing the messages, the socket is free to receive other chunks. In this way, you parse and you always have the buffer full in the socket, because most of the time you have to wait the data from the server. And the last one was to rewrite from scratch the protocol that we use to store the messages inside the protocol, the server. And this because the AMQP 1.0 is big, is complex, but we need only a part of the protocol, so we decide to rewrite it from scratch. Solution, problem solved. We moved for 35 seconds to 12 seconds to download 88 million of the messages. So I left to the slide a pull request in case someone is interested to understand how we did. Nothing special. So I didn't have a lot of experience in .NET, so I just followed some old best practice. And yes, that was a very big improvement. Okay, the second one is about Golang, and speaking about Golang, I decided to report another kind of the problem that is a latency problem. As you know, throughput and latency can't live in the same session because there are users that are looking for throughput and the users that are looking for latency. The user said something like, I did tests and blah, 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 and I got a latency 200 milliseconds, which is too high. I know, it seems strange, but we have to deal with this kind of the numbers. Sometimes I'd like to speak with the user to say, why is too high? What you have to do with 200 milliseconds? But this is the number that we have to deal more or less every day. So the solution for this kind of the problem was come on. No. The solution was not to cut the code because Golang, as you know, if you use Golang, the Golang itself is already an essential, language, and we didn't have a lot of layers, but the solution was more to find the right balance for the client. The client was designed mostly for throughput, and we had to try to find the balance. How? First of all, we decided to change the buffer I/O writer to the writer. Do you know, if you use Golang, do you know this structure, buffer, writer, etc., etc.? The difference is that the buffer I/O writer is best for throughput, and the writer is best for latency, because the buffer I/O writer creates a sort of internal buffer, blah, 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 and is always copy, etc. The writer just writes what you have, which is faster. And the second one was to replace the binary read. That is a very cool function that you can find in the Go library, standard library, but is a bit slow because each time that you want to decode a type, let's say integer, unsigned integer, or blah, 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 each time there is a sort of reflection to understand the type, and then to decode the type. And this is slow. Usually you don't care, but again, millions of this reflection can be slow. When you know the protocol is better to decode the data that you know. And the last one was to provide a low-level API, because synchronous low-level API, because work asynchronous is cool, we like, and blah, 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 but sometimes you need to understand where the data are sent to the socket. So we provide a different, another API basically, so the user can aggregate the messages and send the messages in a synchronous way to the socket. As I said, we wanted to provide just one interface to the user to handle more or less all the use case, but we had to provide another, another API, because it's always hard to find the right compromise between them. So after this optimization, this is the comment from the users, so 10 times faster. And I hope that now the user is happy, because under this, I don't know what we could do. And the code was a bit more complex, and more API, we had to provide more API, but again, when you have to deal with the complex problem, you need complex drivers. So what we learned? We learned that elegant, even if this is not so elegant, but this is the first image that I found. Elegant, sometimes elegant or clean doesn't mean fast. Sometimes you need to drop and to cut all the layers that you don't need. And with this slice, I'd like to say Forza Ferrari, always. And you need to cut all the layers, you need to go essential, even if it's hard to drive, even if it's hard to use. Let's conclude, because I have 3 minutes. If you use Golang, I really suggest to you check the sync packages, because there are a lot of cool functions like mutex or signals, or there is a struct that is called like sync pool, which is a function that you can use to reuse the same memory allocation. In this way, you don't need to allocate and use. You can reuse the allocation memory. The only difference is that the sync pool uses always the heap instead of the stack. So you need to find the right compromise. .NET, I didn't have a lot of experience in .NET, and it was a surprise because I really like .NET, can be extremely fast. The only problem with .NET is very huge. So in order to find your library or your class or your framework is always hard, because it's very, very huge, and you can do the same stuff in different way. Allocation, as I said, is not free. It's better to reuse the memory. It's better to have one static allocation and reuse the memory instead of drop and reallocation, especially when you have garbage collector, because a lot of stuff are involved. Serialization is expensive, especially when you use, for example, JSON serialization or text serialization that usually use reflection stuff are usually slow. And the last one is that dirty sometimes is the faster way. So in order to be fast, you need to be a bit dirty. This is why I usually add a lot of comments on the code, not only for the community, but for myself, because I usually forget the stuff after 5 or 6 minutes. So it's for myself in the future. In this way, even if the code maybe is more complex, with the comments you can help also people that wants to contribute in your repository. I finished, just to let you know, if you want to go more about RabbitMQ, stream, blah, 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 I will be around. If you speak Italian, there is a channel in Telegram where we speak about RabbitMQ, and also on a YouTube channel where I share some short video about RabbitMQ. That's it. Thank you.
Thank you very much, Gabriele. Is there any question from the public? No? Oh, yes, okay. Can you please stand up?
As more a curiosity, you mentioned many different drivers that you are producing, making available. You didn't mention the one I use, which is Pika, but I was curious to know which one is the most used, if you know.
The client, you mean?
Yeah.
At the moment, the most client is the .NET client. And this is why, at the moment, the Java client and the .NET clients are the more stable and the more performance client. We have a lot of clients involved, and we have to try to find the right compromise, because our team is low, and we hope the community will help, for example, in Node.js, Rust, Python. If you want to help, you are welcome. Okay, thank you.
Thank you very much. Ano, another questions? Have you, can you survive a little bit more?
I don't know.
Can you please stand up?
Hello. I don't know if it's the right place to ask. We are also looking in RabbitMQ right now, and also in other products like Kafka or the proprietary ones like PubSub from Google Cloud. What do you think is the main, the best use case for RabbitMQ, and why should we use RabbitMQ for our company?
Okay, so RabbitMQ was designed to handle the MQP 091 protocol, which is I send the message, I consume the message, I remove the message. The new part is the streaming part that we want to handle other use case like streamings, like, I don't know, you want to aggregate logs, you want to keep your history in your system, you want to trace your history in your system, and you want to replace, reread the history. I don't want to mention event store because it's not properly correct, but this is more or less what we want to handle. And the difference, for example, between Kafka, let's say, and RabbitMQ is that Kafka is focusing on streaming. In RabbitMQ, you can handle different protocols like MQTT, WebSocket, MQP, and Stream all together in the same broker. So Kafka is more maybe focused on streaming and is more complex with streaming. RabbitMQ is more essential in streaming, but you can use different protocols together in the same broker. I know that the answer is generic, but I will be around if you want to speak. I will be glad to speak with you about that. Thank you.
Thank you, Gabriele. So now we close this speech, and so we will come back in just 2 minutes for the next speak and the next adventure, I would say. Okay. So I will start to introduce the next speaker. So I kindly invite the people who are talking also with the previous speaker to talk not so loud. And so I will introduce the next speaker. He's Luca Guadagnini, a solution architect from Cherry Chain, born in Trento, passionate developer, interested in software architecture, domain-driven design. One interesting thing is that he enjoys reading Greek mythology essays. That's very interesting because now we are going in our next adventure. So get ready to sail from the Scylla and Charybdis shores of three-layer architecture to the safe Ithaca, refreshing shores of clean and hexagon architecture. Welcome on stage. The floor is yours.
Hi everyone, thank you to be here for this new adventure for this talk. So what are we talking about? We're talking about clean and hexagonal architecture, and more in general, some fundamental principles for a good software architecture. Let's move on. Well, I will skip this slide because, yeah, I got already a good presentation. So, yeah, as I said before, I'm very interested also in Greek mythology. So, our adventure is entitled Odyssey. Why? Because build a good software architecture is just an odyssey. The first chapter, we're going to see what is a software architecture. And the second one, we try to face a software architecture with a common approach, with a three-layer architecture, and we're going to see some use case scenario that I had to face. And another one is the last chapter is about principles of clean architecture, and then how to implement a clean architecture with hexagonal architecture. So, what are you talking about when we're talking about software architecture? Usually, we always think, well, the junior developers always think, building software should be easy. Well, it's not very in this way. So when we talk about software architecture, we're talking about the software elements that help us for reasoning about our system. So we try to organize all the software elements with such relations, and then we try them to put in some packages or models, and we try to create the dependencies on them. However, we need to face a particular monster, the stakeholder monster. And when he tried to ask us, is all software good enough? We usually say, nobody knows, pun intended. So what can I do to be sure if our software architecture is quite good? Well, we need to face some quality attributes. Quality attributes are just guidelines to see if our architecture is good enough. These are a bunch of them. There are plenty of them, usually, and we don't try to solve them all because it depends on the system that we are trying to build. Instead, we have to focus on guidelines. Guidelines are not laws. They are just something that you want to follow, or rather, you want to find what is useful for you in such guidelines. And these are just a few dots, if we want to know about the process guidelines, for instance. When we talk about software architecture, we need an open discussion between architecture lead and the developers. And then we need to specify, to focus and specify the quality attributes that we want to meet against the stakeholder needs. Then, yes, of course, documentation. Documentation is always good for a software architecture. And another guideline, fundamental guideline that I suggest is create a working skeleton, so with no integration. That is just a very easy and plain object in order to face some initial user cases. And then we try to incrementally grow the system. The other one is the structured guidelines. So we try to modularize our architecture and to follow, well, to try to solve some quality attributes. There are some well-known architectural patterns. We need to be platform and tool independent, and we try to always segregate the write and the read sides. That is, we need to separate the software element that produce data from the ones that consume data. Yeah, and design patterns are refined. So a common approach to software architecture is the three-layer architecture. This is a typical image of a three-layer architecture, and it's a very old one. We got the persistence layer, the business layer, where all the business rules are, and then the presentation layer, that is a UI presentation. So how to handle that? You get the user interface and the process control and the scheduler are elements for apply business rules. And then, I don't know, we get a blocking I/O driver or a file in order to face a persistence layer, or a RabbitMQ client if you want. Is all this good enough? Well, maybe during when you try to grow your system, you need other kind of layers. So, I don't know, the database layer, and then the web API layer. So, the three-layer architecture is no more, and we have something bigger, n-layer architecture. However, if your system still is a single unit, deployment unit, quality attributes such as deployability, modifiability, and testability are met. And it's a quite easy and simple architecture in this order. However, I want to share a personal story. When we started to create something like this, so we replicate some business rules in the mobile presentation, and this started to be a little bit a problem, because it was very hard to modify it, because we needed to replicate the business rules in the web application, and then also in the mobile presentation. By why all of this? Because there was an open discussion between the architecture lead and the developers. So we always, we actually try to be open to all modification on our systems, but then we lose control about them. So the modifiability is lost, deployability is lost, and then the testability is lost. So the simplest solution when we need to answer to the stakeholder is the runaway pattern, but it was a joke, actually. What really matters in all of this, it doesn't matter if you have an n-layer architecture, but because the most important part of it is the business layer, where all the business rules are. Because in such layer, you get all the use cases scenario for your application and for your system. So how to be clean and hexagonal then? Let's start to be clean. Domain entities. Domain entities are domain actors for your business domain. So you need to have a very strong focus on what are the actors for your use cases. Then you have to implement the use cases in the scenario that are able to use such domain entities. And then there are internal services like controllers, gateways, and presenters that interact with the use cases. And finally, we got external services. web API, database, and the UI. But how to implement such a clean architecture? One implementation is possible with hexagonal architecture. Hexagonal architecture has a core in the middle of in this ocean of user interface and infrastructure. And the domain model is actually our domain entities. Then we get the domain services, and that is the use case scenarios that we are going to implement. And then the application core. The application core is the kernel of the whole application. It must be isolated from all the interaction from outside. And most importantly, should be framework-less. So you don't need to implement application core with a framework. Or usually, it's very hard to do it because frameworks are a very useful thing. But this it's possible, I suggest to do that because then you can bring the core wherever you want, and it's much easier to introduce new cases, use cases scenario. Then how to handle the request? In order to interact with the application core, we have this software element named port, and actually they are ingress port. And then we got the web adapter, or adapters in general. Adapters are a wrapper around the port in order to interact with the application core. Finally, we got the other kind of adapters, because if the ingress adapter try to interact with the input, they produce a sort of output with two other ports. So we have the egress ports and the egress adapters for other kind of services, such as databases or email provider, etc. The last part is to slice and dice our architecture in order to create the components. So components is just another one use case scenario, for example. So what we learned, software architecture is not easy, and the process structural steps are essential, so you need to focus on them. And then team communication is part of architectural tactics, so you need to care a bit about it. Business domain always rules. And then component isolation for the better, and great mythology is awesome. So yeah, I can skip that because it's too much. And then keep and be interested about the poor stakeholder. So please, nobody, let me know if everything works. So thank you for listening. Then we got some references for software architecture and software architecture in practice, fundamentals of software architecture, clean architecture, and other kind of books about Java instead. So thanks for listening.
From the public, we have minutes, so we have time, so we can take a couple of questions if anybody has them. No, otherwise there was a wonderful experience. Thank you very much. And so we wait for a couple of minutes.
Thank you.
Thank you. Okay. So, yes, 1 minute to go to our next speaker. And I will start to introduce her by saying that she is a free software advocate since 2007. In 2010, she was one of the first Italian members of the LibreOffice community. She served as a board member of the Document Foundation, also was member of the membership committee at the Document Foundation, then active member of the DORA project and open source advocate since October 2011. So she co-founded also Associazione Libre Italia, and since 2020, Marina works at SUSE as a software release engineer. She will tell us about accessibility improvements of UUnii, who is a powerful open source configuration and infrastructure management tool used by many organizations. Welcome on stage, Marina, the floor is yours.
Thanks for the introduction. And of course, thanks also for joining. Today, I would like to give you some insight on this specific project that we have done during the recent Google Summer of Code. And yeah, as the title suggests, I want to talk a bit about UUnii and also accessibility. And I would like also to give you some insight on things that you should take care of in general for your open source project. But talking about UUnii, first of all, why this name? UUnii takes its name from the Salar de Uyuni. It's a place in Bolivia, and it's a really huge salt flat. Actually, it's the biggest in the world, and the name has been chosen because Uyuni, salt, is indeed the main technology behind the product. So, of course, we are geeks and we like to give weird names that no one can understand outside the project, but, you know, it's open source and it's how we are working. So, Uyuni. Then, of course, UUnii is a solution that can be used for handling the configuration, but in general also for doing the management of infrastructure. You can use it for doing the CV scan. You can do some remediation also, checking with the OVAL. So with OpenSCAP, the setup of your infrastructure. So it's a really complex tool that can be used for handling really big infrastructure. And for infrastructure, I mean not Windows infrastructure, but Linux infrastructure. And we like also to underline that UUnii is not used only for a specific kind of Linux distribution, but you can use it for managing, of course, SUSE, OpenSUSE distributions, but also Red Hat and all the flavors. The same applies to Debian, Ubuntu. So it's really a distribution agnostic tool. And it's open source, so everyone can contribute, and you can also help to implement the support for new operating systems if they are not supported. But back to this specific project, accessibility. It's something that in every open source project we should try to take care of a little bit more, because we know that normally, really, working on accessibility is the last thing that we are always touching, because there's never enough time, resources, and so on. But actually, if we want to really provide open source software that has the extra value, we should also take care of its accessibility. And UUnii is using, of course, can be used via command line, but the main way to use it is to use it via a web interface. And when we need to work with something that should be really accessible, means that we need to take care of a web interface that can be used by people that could have disabilities or some kind of impairments, but at the same time,
if the product is really accessible, also everyone else will get benefits from this kind of extra implementation. And there is, of course, the good reason of inclusion, and that one is probably the one that everyone working or dealing with open source software could have in mind. Improving the accessibility will improve the inclusion in a project, in a product. But it's not only that. When the accessibility is provided in the right way, of course, the user experience will also improve. And last but not least, the legal compliance, because there are in several countries also requirements on accessibility. And if, as open source community, we want to try to have our open source softwares really used and adopted, we need to take care also of this kind of issues. And for this specific project, I mean, I'm talking about accessibility, so there is the guidelines, that is the Web Content Accessibility Guidelines, and this, it's, let's say, classified in 3 different steps, and it's a guideline. It's not something extremely strict, but of course, according to which level of accessibility someone wants to provide, you can decide how deep you want to go with the changes, with the implementation that you need to work on. And for this specific project, we tried to go with the level in between, where the focus was also to take care of the contrast, take care of the right support, the zoom level, the shortcut, for example, in the web interface. So starting from the guidelines, we decided to work on this set of improvements. And as I mentioned before, keyboard shortcuts, the color contrast, the alternative text for the images, for the icons, the accessibility of the forms that are in the web interface, and last but not least, it's important also to focus on the navigation that should be consistent and well-structured. We selected this kind of requirements because, as I mentioned, this project is something that we handled during the Google Summer of Code, so the time was limited, and we tried to organize something that was possible to be achieved by the intern that was working on this specific project. And we had the intern, Rachel, and we were 2 mentors, myself and another colleague from SUSE, and we organized the project with some weekly meetings, with a dedicated chat on Gitter, because the Uni community is using Gitter, but I mean, part of the project was not just working on the accessibility, but also mentoring. And for making her contributions a bit easier, we decided to make also a safe space for the intern, having a private chat where only the 3 of us were just discussing daily, trying to push also her to interact also with the rest of the community. And yeah, of course, the community, the Uni community and the Uni project has the source code directly on GitHub. So we had a board on GitHub, and everything was, of course, open source, so made available in public to everyone. So this was, let's say, the organization, the internal organization of the activities. But talking about tools, we used Wave, and this is something that I really suggest you if you want to quickly check the status of the accessibility of your project. This web accessibility evaluation tool is really a comfy extension for the browser. the screenshot is from the Chrome web store, but actually there is the same extension also for Firefox, so it's not something Chrome specific. And it's easy, you can install the extension, and then from the toolbar, you can decide when to enable the extension and start to evaluate the status of your web interface. And this is the result. You have a summary like this, with the general view of the status, and then you can dig into every category, looking into the details, and decide on what you want to focus. For instance, this is a selection of the different view with the different kind of reports, and you can't fix everything altogether. So normally, it's good to start from the errors. Then you can decide if you want to go on alerts or other features. And the nice thing is that tool is providing you the icons that you can click, and immediately you will have the highlight of the status on the web page. With some extra details on what should be fixed and how to fix it properly for having the test passing. And this is the view. So this one is the main login page for Uni. And if you switch on or off the extension, you will see immediately where are the problems. And you can click and see the details and navigate it. In the down part, this part normally is going up and down when you click it, and you have the source code. So it's really easy to evaluate the issues, to see where to start to work. And of course, we started from the login page, then going into the first overview of Uyuni. We decided, we selected the first areas where to start to work on. We had a custom branch where Rachel was providing the fixes, we were doing the reviews and so on, and that was also another way to make her life a little bit easier. And with that, we had some good progress. The project, of course, is not ended. There's still a lot to do, but there are already some good results. And yeah, the project, the official Summer of Code project is ended, but we are still progressing on more changes. If you are curious, at this link, you can see the final report, and from there are also the other details from her experience with all the links to the board, the source code, and so on. And of course, if you are more curious about Uyuni, this one is the contact page where you can find all the references for the community, the user guide, the API references, how to download it, and of course, the source code. And with this, I'm done. If you have any question, I'm happy to try to answer. Thanks a lot.
Thank you, Marina, very much. Are there any questions from the public? No, not really. Okay. So thank you, Marina, very much. And we do another applause because she didn't receive a one at the beginning. So another applause for Marina. So now I just use these couple of spare minutes that we have to say thank you to you. Because now my moderator role is finished for today, and I hand over for the next session in this room to Marty Rabanser, who will be the moderator of the next session, starting at sharp 2 p.m. So you have 6 minutes, and I hope that you will enjoy SFSCon today and tomorrow as well, and you have a fruitful discussion with people, and we thank our sponsor, the teams, the speaker, of course, and all the participants. So thank you so much, and see you around.